last guests would just like to come in and take your seats, we're going to open the Congress, the second edition of the Chenin Blanc International Congress in a few seconds. Good. Okay, so I'm going to call immediately Madame Mathilde Fauvedan, who is the Deputy Mayor of the Outreach and Tourism and the President of Destination Angers. Et je vais vous laisser parler tout de suite. Je vous laisse avancer peut-être là.
Hello, hello everybody. Thank you, Nareta. So, I'm very pleased to be there for the second Congress. So, the International Chenin Blanc Congress in the city of Stellenbosch follows the success of the first Congress launched in France in Angers in July 2019, with more than 324 delegates from 13 nationalities. You were more than 40 South African delegates to travel to Angers. I cannot help but think of the genesis of this event, supported by the Académie du Chenin, in close collaboration with the Destination Angers, in partnership with the Wine Federation Anjou-Saumur, Touraine-Sarthe, and Interloire, and of course, with the support of Mr. Christophe Béchu, our former mayor, current French Minister of Ecological Transition and Territorial Cohesion. Choosing South Africa and Stellenbosch to organize the second meeting makes sense on several points. South Africa is the first producer of Chenin with France, just behind. In 2020, in the Loire Valley, Chenin is also the fourth most planted grape variety. The Stellenbosch terroir is traditionally famous for its white wine and the highly quality, more than 20% of which are planted with Chenin. Chenin is a grape variety with powerful radiation as it arouses significant adjective during its tasting. Round, fruity, acidulous, tender, sweet, mellow, a grape variety that makes us live emotions. The emblematic grape variety of Anjou has brought us together and bring us together again today. A link has been created with Stellenbosch to build the second edition, which promises us once again beautiful exchanges and beautiful scientific advances at a time when climate change is in everyone's mind. I would like to give a special thanks to Ken Forrester. Thank you. Nolin, of course, and dear Ina, which is with us today from CBA, for all work, investment in the preparation of this second edition that will be presented to you later. I also thank Evelyne and Patrick from Académie du Chenin, Sylvain, Sophie, Josepha for the organization of the Anjou-Saumur delegation. I don't know where they are. Thank you, of course, to organize everything. And maybe Tanya for the Vouvray part. Also 30 people. I would also like to thank Mr. Mike Radcliffe from CEO Visit Stellenbosch as host Destination Management Organization to welcome us here in Stellenbosch for a few days and for the participation to social and tourism program. Mr. André Morgenthal, head of the Old Vine Project, co-host of Chenin Congress 2022, and for his testimony for the first Congress in 2019 in Angers. And also Mr. Laurent Alberti, the French Consul General in Le Cap, who honor us of his presence and on the opening ceremony for this morning. As Deputy Mayor of Angers City and President of Destination Angers, brand owner and global player of the CBIC, I declare open the second edition of the Chenin International Congress and wish you all a great time of exploration and discovery. Thank you.
Merci Mathilde. And thank you also for bringing the Congress to South Africa and in particular to Stellenbosch. Just a very warm welcome. Peut-être juste quelque chose de technique. Vous avez
just some technical questions. There are interpreters here, and you can choose your language. We are going to be speaking French and English, but I think you are going to have excellent exchanges in English or in French. So,
of course, to Mathilde, to the Consul Général du Cap, Monsieur Alberti, who with the Ambassade de France and even with France, soutient énormément la collaboration.
Supports the collaboration between France and South Africa, and by science, research and innovation, and we would therefore like to thank you for being here today, of course, and it's an excellent example, isn't it, this Congress, that is testimony of this collaboration between two associations and two associations.
Almost 70 guests from Vouvray and d'Anjou. Donc I think you've beaten us, because at the first Congress we were about 45 South Africans that traveled. Okay, so this is the second edition. Of course, very welcome to l'Académie du Chenin, Madame Evelyne. Pardon, je vois pas Madame. Ah voilà, Evelyne, venez me rejoindre. Vous allez faire une intervention avec Ken.
You are going to be doing a presentation with Ken Forrester on the topic of this Congress, which is entitled Reveal of Place Chenin Blanc.
Ken Forrester, le président de l'association du Chenin Blanc.
The Chenin Blanc Association.
Also a special thank you from my side and from the South African side to Ina Smith, who not only is the manager of the Chenin Blanc Association, but also the organizer of the Congress. Then, on a parlé bien sûr,
we are also
from Swan Valley. I don't, very welcome. Thank you, very welcome. We welcome you in South Africa. And of course, the South African wine industry, and our producers and our experts who are here today also welcome South Africa and welcome to Stellenbosch in particular. Stellenbosch, c'est un peu le berceau.
Stellenbosch is the heart of our profession, if you like. So we are very happy to welcome you here in Stellenbosch, and especially in cities.
And for this wonderful venue. And we will speak about our sponsors on the last day of the Congress. So without speaking of Stellenbosch, I would like to call Monsieur le Président, Monsieur Ratliff, Mike, if you could join us please on stage as well. And also André Morgenthal, if you could, you're not getting away. So Mike, I would like maybe to hand over to you. Mike maybe needs no introduction. In France, we call him Monsieur Marketing Mike. Mike is the chairman of Visit Stellenbosch, and also of the Stellenbosch Wine Routes, positioning Stellenbosch as not only a wine tourism, but really as a business tourism destination in the world. And you will talk a little bit more about that. But you're also the MD and the co-founder of Villa Fonte, who has worked and contributed largely to the premiumisation of not only the Stellenbosch wine industry and its appellation, but also the South African industry as a whole. Mike, very welcome, and merci beaucoup.
Well, thanks. Good morning, everyone. It's great to be here, and very specifically on behalf of the entire Stellenbosch wine community and the Stellenbosch tourism community, you really are welcome to our beautiful town. I can see that the day has started well. Stellenbosch is showing off, and may it continue to do that. I've been given 5 minutes to speak. I'll do it in 3. Stellenbosch is it's a diverse region. It encompasses multiple terroirs, multiple personalities, an incredible diversity of terroir, and there's no way that we can fit into a single box. But we do have a huge number of very strong interest groups and a lot of great success stories, and one of those, perhaps the most dominant, is Chenin Blanc, and for that reason it feels really appropriate that you're all here in our little town today. We have Stellenbosch can almost be seen as a home base for Chenin Blanc. By volume, we have a large proportion of Chenin Blanc from South Africa, and a lot of the old vines, Chenin Blanc vines of South Africa, are based in Stellenbosch, so once again, appropriate. But given the size and the strength of Stellenbosch, we do take our leadership very seriously. It's important that Stellenbosch leads not just for our own region, but for the entire country, and I think today is part of that. Also, as part of that, we are very happy that we have the university in our town, a bastion and a pillar of our town, a center of learning, a center of training, and it's again appropriate that we are here at STIAS today. Hopefully today will be the continuation of a great partnership with not just Angers, with France, with Chenin Blanc, a continuation of great friendship between our towns, continuation of great cooperation and learning and building on this wonderful platform that is the Chenin Blanc International Congress. So Stellenbosch says a great welcome. On behalf of the town, it would be inopportune to not say thank you to the Chenin Blanc International Congress, also to Destination Angers, the Chenin Blanc Association that has put so much work into everything today, the Académie de Chenin, and mostly, if I can leave one word, may we start and finish the week with great friendship. Thank you very much.
Excellent. So maybe, I did forget to introduce myself, like a good MC should do. So, je m'appelle Narieta Ricom. Je suis
My name is Narieta Ricom, and we represent producers and in France, but also in South Africa, and we are also owners of l'Avenir Stellenbosch Vineyards, and we have Ken Forrester, Kleine Zals, donc des domaines ici à Stellenbosch, and I'm very happy as well to be present here. I work in the industry, I work between France and South Africa, and we are also very pleased to welcome you all here. I would therefore like to now give the floor to Andre.
Award an ambassador of old vines, and always promoting the old vines of South Africa. You are also the co-host of the Congress and have put wonderful afternoon programs together so that our producers and our guests can experience also the terroir of Stellenbosch. Maybe, Andre, just a little word on the Old Vine Chenin project. It is a wonderful certification where producers, en fait, les producteurs en Afrique du Sud.
So the South African producers certify the wines, which enables us to trace the dates of the plantations, of the vineyard, and also...
And so this certification is also a wonderful step and ties very well in with what the Chenin Blanc Association is doing, and also the ascension and the whole notion of terroir and, you know, the going up of the perception of Stellenbosch, the Cape, and the South African wine industry. So, Andre, welcome here, and maybe just a few words on that, or as you wish.
Merci beaucoup, Narita, and welcome everybody. I've in fact been asked to speak about the reflections on the 2019 Congress. I'm going to touch on old wine, but I think Narita did a great job there for me. And when I thought of our reflections, the first thing I remembered was arriving at Charles de Gaulle with my travel partner, Johan Burger. He's in the audience and he's speaking later at the conference. He's with the Department of Genetics. And we arrived at Charles de Gaulle and we saw a cluster of South Africans, and it was the Bread Maker group. Some of you will be going there on Friday. We boarded the train to Angers, and it was one of the most exciting train rides on the way. We suffered from somewhat of arrival anxiety, which we also noticed in the group last night at the Kaapse Braai again. They were pretty excited to be here, and so were we. And arriving in Angers, we soon realized that Chenin brings people together. And then also that Chenin brings international wine regions together at the first international Chenin Blanc Congress in Angers. That was 2019, where our plans to receive you in South Africa was brought to a halt by a rather international flap, caused by a small microbe that resembles a fugu, a Japanese delicacy also known as a puffer fish. If approached without caution, can be fatal. But here we are. The Chenin Blanc brings us together again, here in South Africa in 2022, with our friends in Chenin from Loire, and some fellows from India, Germany, and Australia. As we experienced during the 2019 Congress, we'll taste a vast amount of some of the best Chenins in the world, complemented by vineyard visits. These visits have been carefully selected and be practical, but also tie in with the theme, Chenin, revealer of place. Vineyards with heritage, culture, the people, sometimes generations, telling the stories. I once heard a winemaker said, all vineyards have numbers. Give it a name, tell the story, reveal its identity. The South African representation was significant in 2019, as was mentioned earlier. But the Loire 2022 French delegation is almost double, and don't discount the 2 Australian visitors. We are so excited to share with you our Chenin heritage and stories, like you did with us so generously in 2019. But let's think beyond hospitality, sharing knowledge, good practice in the vineyard and the cellar for the international future of Chenin Blanc. So during the road trip post-Congress, which Grand Dame of Chenin, Tannie Ina, organized for us, we visited some very special vineyards, and we soon realized again that with Chenin, it will always be the most beautiful day of your life. Here, we hope that it will be the most beautiful week of your life with Chenin in South Africa, similar to what we had with you in the Loire in 2019. Merci beaucoup.
A wonderful message of resilience also. So the vineyards, they teach us well. Professor Wim de Villiers. Waar is professor? Professor, welkom. Ek het u nie vroeër vandag gesien nie. Nou het ons nie, ons het 'n, ja, presies, ons het nie 'n stoel vir u nie. So Professor, daarom net noem, so Professor Wim de Villiers is the Vice Chancellor and Rector also here at the University of Stellenbosch. Stellenbosch, of course, professor since 2015, and you have always also traveled the world, held some very important positions across the university, Kentucky, also Harvard student, Oxford, came back and is driving the University of Stellenbosch to be an absolute think tank and really push innovation and research and science, and has been a wonderful support to the South African and the Stellenbosch wine industry. Thank you, Professor.
Thank you very much. There's hardly anything left for me to say. So I'm Wim de Villiers. I'm the Rector and Vice Chancellor of Stellenbosch University. And it's a real pleasure to welcome you here this morning. Bonjour, mes amis. Ça va? Quoi de neuf? So, good morning, distinguished guests, colleagues, students, delegates, and researchers from South Africa, France, and further afield. I'm not only the Rector and Vice Chancellor, I'm also a gastroenterologist by training, so I'm a specialist physician. So I can tell you that wine is good for you. In moderation. But it's truly wonderful to welcome you to Stellenbosch University and our beautiful town, and also South Africa's wine country. So one of the favorite movies that I can remember, of course, and many of you probably know as well, is Sideways. All right. And there's some of the most wonderful text and commentary in that movie on the appreciation of wine. And I'm by no means a wine connoisseur, but I loved just listening to the actors talk about wine. Of course, we all know that it didn't do much for the sales of Merlot, all right, following that movie. So if you don't know the movie, you've got to go and watch the movie. But a few years ago, the UK's Guardian newspaper ran a column by the wine critic Fiona Beckett with a specific focus on Chenin Blanc. And she wrote, "Good Chenin is ideal for people who secretly like Chardonnay but don't care to admit it." But I mean, today I'm sure there's no one in this room who is at all ashamed to admit that Chenin Blanc is their preference. And I must say, it's my preference as well. So it's a real pleasure to be here. But it comes back to what the Deputy Mayor said a little bit. She went on to use the words, and I like this, rich, voluptuous, lush, and astonishingly good when it came to South African Chenin especially. And so today's this conference with a focus on cultivation, winemaking, and marketing really brings together such a large number of you. I hear 230 of you, researchers, experts with a passion for wine. So Stellenbosch University and the town itself, where we're known for our impact on the wine industry, and we're the only university in the country that offers qualifications in viticulture and enology, and we have a long-standing undergraduate program in this field. And our academics are doing very impactful collaborative research. We're a university of 32,000 students, more than 32,000 students, 2/3 undergraduate, 1/3 postgraduate. We also have more than 4,000, almost 4,500 international students. 60% of them are from the African continent. Zimbabwe, Namibia, number 1 or number 2 interchangeably. But very interestingly, especially over the last 2 years, you may have noticed if you wander the streets of Stellenbosch, you'll find every semester or so 400 to 500 French students in town. And they're from one of the top-notch French business schools, Schema, and they do either a bachelor's in business administration or a master's in business administration. So there's no question that Stellenbosch University, and if you actually look at the vineyards outside STIAS here, the Stellenbosch Institute of Advanced Study, there's some Pinotage vines here that actually stem from some of the original vines that Professor Pierrolt developed in 1925. So the institution has played a very prominent role in cultivating new generations of farmers, winemakers, and wine industry professionals. And Chenin Blanc, as a wine, has also played a very prominent role in promoting and securing our standing within the international wine community. So it's really a pleasure to welcome this wonderful international community to our shores. It is probably still too early in the morning to say cheers, but I do raise a figurative glass to the success of the conference, and I'm sure that this will be a great conference. Merci beaucoup, and the doctor says, go for it, enjoy, in moderation, please. Thank you.
Professor. And we will finish or close off and leave the last word to Monsieur le Consul Général, Monsieur Laurent Alberti. Merci beaucoup. Le dernier mot, c'est pour vous.
Je vous remercie. Bonjour, bonjour à tous. Good morning. Goedemorgen. Well, it's a pleasure for me to be here. English en niet Afrikaans niet, want er is niet een vertaling. So yeah, thanks for being here all together. I think all the people here are people who have a passion, because passion of wine, that's a passion deeply rooted in the French and South African cultures. At the Consul General of France here in South Africa, it's a pleasure to be in Cape Town, at the heart of the wine region, the wine area, surrounded by these beautiful surroundings and by a community of South Africans and French that are committed to working together, especially in the field of the wine industry. On my personal story, I discovered Chenin Blanc when I was living in Holland. When I was living in Amsterdam, at that time there were lots of South African wines everywhere, and they all had this wonderful Afrikaans name that Dutch people love. So everybody loved the wine from Stellenbosch, Franshoek, Eenzaamheid, Vergelegen. And suddenly in the middle I saw this Chenin Blanc. I said, oh, South African wine with a French name. What's that? And that's how I discovered Chenin Blanc. That was quite a while ago. And that was the start of also my love story with the Chenin Blanc. This marriage, wine is a marriage between man and land in France and in South Africa. And when we see the beautiful surroundings here, we understand that the French Huguenots loved to settle in this beautiful area in the 17th century. Today, wine industry has grown so much in South Africa that always people ask me, oh, but as a Frenchman, it must be difficult to be in South Africa because you've got your own wine. And I say, well, but I love South African wine so much. I smuggle them to France when I travel back to my family, actually. Because South African wines have reached such a level. They're so famous that in all the countries where I lived, in Hungary, in Germany, in Holland, of course, and more in France. It's a real pleasure to see that the French customers who are used to having their French wine are also discovering foreign wines, and the cooperation that we're building in this field is very important. As the French consulate in Cape Town, so our aim is to strengthen, reinforce the cooperation between our two countries in the field of wine industry, so we can help entrepreneurs, French entrepreneurs coming to the Cape area to deal with different groups, with people involved in business. We work with Westgrow, the investment agency of the Western Cape, when they have investors who want to come to France. And we also have developed a partnership with different universities and with Elsenburg College. And in this in the framework of the agreement signed between the province of the Western Cape and the Bourgogne-Franche-Comté area, there are several lots of students. We have what we call in French the échange d'apprentis. Like 200 from South Africa went to France, to Beaune in Burgundy, and 50 French students came. And these are the young people who are starting in the wine industry and trying to get a better understanding of the best practices here and there. So we are proud and glad to see how powerful this passion of wine can bring France and South Africa closer, and this event takes part in the writing of this long and magnificent stories. Thank you very much to the French delegates who came from France, and also the people from faraway Australia. Thanks to all the South African friends who love France, and Chenin Blanc is a passion that brings us together. We're really looking forward to having new partnership between the two countries, and if we can be of any help, we will always be very glad to help and try to reinforce the relationship between our two countries and the provinces of the Western Cape, especially when it comes to wine. Thank you. Merci beaucoup.
Merci beaucoup. So, and as you can see, Monsieur le Consul, don't go away, because if I drop or something happens to me, I know you can replace me with Afrikaans. Voilà. Maybe for timing we are good. Wonderful. So I would like for Monsieur Ken Forrester, le président of the Chenin Blanc Association, and maybe to say a word and then also to present with Eveline the theme of this Congress, and I will let you reveal that, but also maybe a little word on you, because when you travel the world in France, and this is not me saying that, he roams in the Châteauneuf du Pape area, and they call him the Pope of Chenin. And I thought that was quite beautiful. So, you know, obviously thank you for what you've done for the varietal and the path that you have traced for all our wonderful, you know, producers and winemakers in South Africa to take that further. Over to you.
Thank you, Noreta. A very warm welcome, and it's wonderful to be here today. Wonderful to have you here under the auspices of the Chenin Blanc Association of South Africa and our partners in France who've come out, all the way out here. And when we look at what happened here 4 years ago, going to a Chenin Blanc Congress in France, and we managed to muster about 40 South Africans, 44 I think, went to France. Fantastic. It was a great event, an incredible event, the most wonderful tastings, the most wonderful presentations, and food for thought. And then shortly after that, the world was virtually brought to a halt. And I think it taught every one of us the absolute power of choice, of time, of not knowing what the future holds. And to see so many people here today from France, I think that's almost a product of where we've been in the last 3 years, that if you want something done, we should do it now. You should choose now. And we look at Chenin, we look at the history that goes behind Chenin. We look at the rich history of our past, of where Chenin started back in the 11th century in France, and where Chenin started in South Africa, and where we are today and where we are right now as almost a speck of sand looking to the future of Chenin Blanc ahead of us, and what will Chenin mean for the future. And I think there's so much to build on, and without any doubt, it's a collaborative effort, it's a team effort. We've had the most fantastic collaboration with the University of Stellenbosch in the last 12 years. Thank you for that. It's been fantastic. Dr. Helene Nieuwoud has driven that, done a fantastic job on research. We've had master's students, honors students, just doing such wonderful work for Chenin Blanc. All of this in collaboration with France. Evelyn has been instrumental. Without Evelyn and Ina, I think, are sisters, perhaps from different mothers, but Evelyn and Ina have got this wonderful bond, and they have really forged a Chenin Blanc path and created a highway where there was no road at all. And they've done a fantastic job jointly, and I think that is the key to the whole success of Chenin Blanc. And it brings us to the topic today of Chenin Blanc as a translator of place. And what does that mean to you, Evelyn?
Tricking me. Well, I think that's what is so interesting in the Chenin Blanc is that in any place where it grows, it produces something different. And it's sometimes very hard to recognize. So it really has a very timid identity, but a wonderful aptitude to express the place where it grows.
And isn't that truly the excitement of Chenin Blanc? When we look at Chenin Blanc, I have people saying to me, only yesterday, was tasting some wines with some people, and they said, well, how is our wine different from the Chenin Blanc in the Loire? And I said, let me explain to you. Our wine is different from one vineyard to the next. Our wine is different from our neighbor's wine. Our wine is different from the people in Paarl. And the Loire has the same problems. Their wines are all different as well. And I think that's not a problem. I think that that's an attribute for Chenin Blanc. I think that really is an attribute and something that we should embrace, because that's truly what makes Chenin Blanc just so intuitively interesting.
Well, Ken, thank you so much for the kind words about Ina and me. But I would like to say thank you to you, because you've been an immense ambassador, especially in the United States, where you travel all the time with your Chenin bottles. You're very well known as being the best ambassador for Chenin. Anyway, before we start this Congress, I just wanted to quote a few dates. So on May 13, 1852,
arrived in South Africa, the first vineyards, the first plants ordered by Jan van Riebeck. No, it's not 1852, it's 1652, sorry. In 1688, the Huguenots arrived, so the French, and they helped with the winemaking. In 1965, the Professor Orfer in South Africa identifies formally that Steen is Chenin Blanc. Before that, nobody realized really that Steen was Chenin Blanc. And in 1999, this was my first visit with the OIV to Stellenbosch. 2019, the Académie du Chenin, Patrick Baudouin and I, organized with Destination Angers and Fédération Viticole d'Anjou the first congress, first international Chenin Blanc International Congress, and 40 of you came from South Africa. Now, this is the second one, 2022, and 70 of us French people are here. And what about 2024? We have to double each time. So really a huge thanks to Ina Smith, to Nolene for organizing all this wonderful congress, and to Ken again, and all the winemakers who are going to welcome us during the trips in the afternoon, and to the University of Stellenbosch. Again, with its diversity of expression, I think Chenin has a great future, because it's very different from the other, from Chardonnay or Sauvignon. So we have to continue to explore its capacities, its problematics, its adaptability, and to communicate in the world, throughout the world.
Thank you, Evelyn, thank you. And I think we're standing, if we look at weather forecasting today, the science of weather forecasting, I think if we just have a look at the weather around the Chenin Blanc industry, around the wine industry today, we could take a dip and say, well, what's happening? There's certainly talk, and we know of global warming, we're familiar with this. What does that mean in terms of drinking patterns? And even large retailers are seeing a trend where red wines are selling less, white wine is selling more. So white wine is growing in popularity. At the same time, globally, we've seen a shortage of Chardonnay due to frosts and due to growing conditions. Sauvignon Blanc has had a similar shortage. So speaking of Sauvignon Blanc, isn't it incredible when the UK press says, well, all you need to know about Liz Truss is that she drinks Sauvignon Blanc? Oh, I didn't say that. but seriously, I mean, God, well done. But if we will have a look at the opportunities that lie in wait for Chenin Blanc, I mean, we are on the brink, we are on the cusp, I think, of really being able to take this variety to the forefront and being the leading white cultivar, without any doubt in my mind. And it's come a long way. You know, in a short 20 years, I can go back 20 years, Chenin Blanc in this country was almost nowhere. It's been a long journey, the Chenin Blanc Association, a committee of committed individuals, and you know, it's not any one person, the committee is just that. A committee of one is hardly efficient. You actually want a broad inclusivity and a broad buy-in, and I think we should just certainly say thank you to my colleagues and to the guys who've actually made all this possible. To be here today is a milestone, and thank you, Evelyn.
Merci beaucoup. Thank you very much to our speakers. I will let or relieve you from the stage chairs. You can stay with me if you want to. And we, with no further ado, we're going to open the session. The terroir and genetics and its challenges. And I would like to call Johan Burger. Monsieur Johan Burger. That's going to talk about the Chenin Clone Project, the what, why, and how of establishing a scientific base for intravarietal diversity.
Just hold your hand.
Yes, you can stay with me. Otherwise, I'm going to be a little bit alone. Voilà.
Thank you very much, Madame MC.
Welcome.
Ladies, gentlemen, it's an absolute joy to be here this morning. And I am speaking in the first scientific session, but the science is going to be few and far between. My very pleasurable task is rather to introduce a collaboration between South Africa and France, no less, that I need to really just introduce the topic. The science will be presented to you in the talk just following my own by my dear colleague and friend, Patrice Thys. So I'm really just going to set the scene, and then Patrice is going to explain exactly what we've been doing over the last year or so. So from my side as well, thank you very much for being here. I didn't realize we're going to have such a massive French delegation here. It is a joy, and I hope you guys will enjoy the conference as much as we did a couple of years ago in Angers. So as I've been introduced, I'm going to talk about what has become known in our world as the Chenin Clone Project, and give you a little bit of background in that. No surprise, I guess, if I say that this all started somewhere between the 2019 conference or Congress in Angers and where we sit today. And we had dinner, Patrice, Valerie and myself had dinner last night, and I said to Patrice, can you remember exactly how this project started? And it was early. We haven't had much to drink by that stage. And truly, we could not really put our finger on exactly how this started. But I can tell you one thing. There are two names that are very prominent in driving this thing. And they are the two tunnies of the Chenin world, Evelyn and Ina. I don't see Ina. Where's Ina? Organizing. Anyway, they were really prominent in prompting us, especially on my side. I can tell you, after the Angers conference, and believe it or not, at that Congress, I spoke about pinotage, not about Chenin. At that stage, I didn't do any work in Chenin, and obviously things have now changed. But after that conference, there was a beautiful article written by a lady by the name of Christelle Zamora in Wine Business magazine. And it says, Chenin Blanc immigrated to the New World 4 centuries ago. Today, this French variety from the Loire Valley is arousing keen interest around the globe thanks to the South African wine industry. And I think that is absolutely made me, of course, in the first place, very proud to be part of this. But it illustrates the very narrow and tight collaboration and interaction between our two countries when it comes especially to Chenin Blanc. So after that conference, Ina told me, listen, at the next conference, that was then decided that it will come to Stellenbosch. She told me from the beginning, at that conference, I want you guys to have done something in Chenin. I said to her, Ina, these things take a while. So the science that we do in genetics takes a while. It's not just something that you can report a year or what later. In one sense, I guess that gave us a little bit of relief or retrieve, the COVID, because it won us an extra year. And we can report today on something that we're not completed, but we're busy doing, and that's what it's all about. So Patrice and I started talking, and we came up with the idea to try and understand the clone situation in the variety. Sorry, I seem to have lost control. Oh, there we go. Okay. So, Evelyn, you just gave some of the history, and I wanted to start with the history as well, with Chenin in the two different countries. As we know, in France, well, I didn't know, I did some research, but it came with many different names, or under different names, like Pinot de Loire, Pinot Blanc, Pinot d'Anjou. And in South Africa, as we know very well, Steen, also at some stage called Fransdruif or Groendruif. All of these things, yeah, sê my jongens Groendruif, I know. You see, you can't speak too out of line, then you get reprimanded from the front chairs here. Thanks, I knew I'm going to get some response. Yeah, so, I'm not an historian, so I cannot vouch for the accuracy of this. I researched the internet, and this is what I came up with. So if it's not totally accurate, please forgive me. But what I see, and what's a bit of a contradiction is I came across that it is believed that Chenin originated in the Loire Valley, fair enough, and around the 9th century. But then also, and I put it in quotation marks there because it's quite different from the previous statement, and that is that there was official French documents that first mentioned Chenin as early as the year 845. That's quite a while ago. So if the second statement is true, it means that Chenin Blanc as a varietal is about 1,200 odd years old. Now, I'm not sure if that's true, but I like the idea. I think it's kind of romantic. So let's assume that is the absolute truth. What was one of the first recorded histories that still exists is this book by the very well-known French author, writer, Rabelais, who wrote in his book Gargantua, where he describes Chenin Blanc as being well-established and well-known varietal in the Loire Valley in the 16th century. So I would take that as recorded history. Chenin Blanc is, as Evelyn has mentioned, came to South Africa right at the beginning, mid-1652. I believe the first plants that were planted in South Africa were Chenin Blanc at around 1655, and then the first wine made ever on the African continent, I believe, was made in 1659 in the Cape Colony at the time, and that apparently was Chenin Blanc. So I think we can decide what we want about the truth of all of those statements, but what I really believe we all agree on is that Chenin Blanc today is really a very versatile and a truly international variety. With versatile, I was absolutely amazed to see the wide spectrum of styles that Chenin Blanc is used for. And then, as indicated, and this came already from the 2019 conference, so the stats here might be slightly outdated, but it gives you an indication of the international stature of Chenin as a varietal. If we look at the situation in South Africa, this map is illustrating some of the main production regions, and as you may know by now, there will be trips to a few of these. I mean, there's going to be a trip to the Swartland, there's going to be a trip to the Brede Kloof. So those are areas that are really the producers of Chenin in South Africa. In terms of statistics, we are getting close to about 60% of all areas under vine in Chenin varietal globally. And we produce a very significant component of the wines made from this beautiful varietal. France, it is pretty similar scenario. It seems to be dominating. 30% of all plantings of vine, Chenin plantings is occurring in the Loire Valley. And for me, a really interesting, and I really did not know this, about 2/3 of all the Chenin produced in France is made into sparkling wine. I really did not know that. For me, really interesting statistic. Let's have a look oops, this has got a bit of a delay, at the taxonomical status of Chenin as a varietal. Just for the scientists amongst us, the family Vitaceae in the plant kingdom, the genus Vitis, the species Vinifera. All of us know that. If you look at varietals, again, a surprise for me was I never realized that there are more than 23,000 grapevine varieties known around the globe. More than 10,000 of this being used for making wine. And then for those of us that were at the conference in Angers will remember the talk where Jean-Michel revealed that the second parent of Chenin Blanc is, I think at that stage, Sauvignon was known, but Sauvignonas was not, and that was confirmed at that conference. So we know now the genetic background for Chenin Blanc. But that brings us then to the core of our current project, and that is the concept of a clone. Now, I'm supposed to be a professor of genetics at Stellenbosch University, And the word clone really implies that two clones would be genetically identical. So the name clone, to use that for something that is got genetic differences, is a bit of a contradiction in terms, really. So I'm going to try, and then I try to understand what does the word clone mean in the viticultural world. And I came across a beautiful quotation from a lecturer in viticulture from the University of California in Davis, a guy by the name of Matthew Fidelibus. And he described clone as old cultivars having accumulated many clones over time, obviously due to mistaken identity, mutations, or both, and both. And that's actually very true. And I think that is also a part of the motivation of what Patrice and myself are trying to do, is to understand how much of what currently is registered as clones are going to be not clones, going to be actually identical. I won't be surprised, and we need to get there, but time will tell. A little bit more formal, I guess, you can define it as a plant in a vineyard that behaves slightly different. People take notice of that, they make a selection of that, they multiply that, and they use that phenotypic expression or whatever is different to register a clone in a particular variety. The problem that we are facing as scientists is that at the moment we really do not have reliable, reproducible, and accurate methods to discriminate clones. And that does not only go for Chenin, it goes for other varietals. I'll give you a couple of examples later in this talk this morning. But that is a problem, especially for wine industry, especially for the viticulture people, especially for the nursery people. They are, in my opinion at least at this stage, propagating and selling clones of Chenin and others more on historical perspectives than brutal raw science. So why clones? As we all know, grapevine is propagated vegetatively, so the genome or the genetic basis thereof is really very stable. It's maintained, it's preserved over time. And the only real differences that can accumulate is over time through absolutely random natural mutations, somatic mutations, i.e. that happens in the plant, you get captured in that plant, that is what is noticed if it has a phenotypical difference, and that can be a color scenario, it can be a taste scenario, it can be anything that distinguishes it from something else, that make people take note of it and find the way to declare it a clone and to propagate it and use it. If we think about it, that would also be the only way that is realistically available to introduce genetic variation. We know, because of the vegetative propagation nature, that the introduction of other genetic influences is not doable. Nowadays, there are amazing technologies that one can do very precise modifications, but in the wine world, in the traditional world, and again we were debating this last night, when and if the genome editing technology, for instance, where we can make tiny changes, when that will one day be acceptable. That's not part of my talk at all. If we look at the types of mutations, they can be very tiny. They can be something that where a single genetic letter is being modified. We call those things SNPs, in single nucleotide polymorphisms. It can be smaller insertions or deletions, or it can be larger chunks of genetic material that are being moved around in the genome in the form of retrotransposons, for instance. These mutations that accumulate can have rather dramatic impact. And a single nucleotide modification can cause something like we've seen that happened in the Pinots. If you compare Pinot Noir, Pinot Gris, and Pinot Blanc, they have mutated naturally over time, and it caused a berry color difference. So it can be quite dramatic in the wine world. And then, like I've suggested, if some of these modifications that happen spontaneously are then associated with a beneficial phenotypic expression of flavor, color, whatever the case may be, that would be a very good motivation to maintain this, to preserve that, and to use that as a new clone of the same varietal. Not all mutations, however, cause genetic changes. There's a different level of modifications that can happen. We call that epigenetics. So those are temporary modification, and it's not because of a change in the genetics. It's a change in methylation, for instance, in expression, controlling elements like promoters, and those things can be reversible. However, they can also be inheritable, so you can maintain them over time. I'm not sure if you're going to talk about that, but that would be another. So then let's have a look at the clonal situation, specifically for Chenin Blanc in the two countries that are collaborating on this project. In France, I believe we have 14 certified clones. They all go by number names, and Andre mentioned that early in his talk that we should name vignettes. We should not just give them numbers. And maybe we should start thinking about doing the same for clones in Chenin. Numbers are rather boring, but anyway. What you see here would be the numbers of the 14 certified clones. You see some of them are in colors, and those are the ones that occur in South Africa as well. So there's quite a bit. I think there are 4 of them that are certified in both countries as official Chenin clones. Interestingly, the vast majority of propagation material in France stem from these clonal selections. I believe, I don't have exact figures, but I believe, Charles, pretty similar in South Africa, I would imagine. We have 12 registered clones, and like you can see, as I've said, some of them coincide with those in France. If we look at the production figures of Chenin clones in South Africa, on the far left, you will see one clone dominating the South African scenario quite significantly, and that is called clone 220, 220. Please put that in the back of your mind, because that number will come up again in a minute or so. I could not find exact figures for similar figures in France, but I'm not sure if you can read. Right on top of their list is clone 220 as well, and the significant difference is the production area for propagation material for 220. As I say, we will come back to those two clone 220s in a while. I want to talk now, just very briefly introduce the genetic kind of analyses that people have been using over time to discriminate varietals and also discriminate. Really? Okay. I can try and get closer to this, sorry. Anyway, let's see how it goes. So traditionally, ampelography was used to discriminate varietals, and viticulturists got really good at that. It was mentioned earlier this morning that Professor Chris Offer used ampelography to confirm that the old Steen in South Africa is actually Chenin Blanc. And from then on, we accept that the two are one and the same thing. So that would be one way. However, that obviously will work up until a certain level, and the level will not go beyond or below a varietal level. Of course, in parallel, there became available molecular tests to do this sort of discrimination between varietals, and at the cultivar level, marker-based selection, discrimination tools like microsatellites and the like were used and can be used to quite comfortably discriminate between grapevine varieties. But when we get to clones, the genetic differences become so minute that these marker-based systems do not work really well. And I list a few of them there as well, like, again, microsatellites, AFLPs, and it's really not important. All of these are based on DNA differences using what we call genetic markers. The issue with those are that we need prior knowledge. We need to know about these differences. They need to be characterized really well before they can be applied as a tool to discriminate. A very interesting paper I came across is where people use hyperspectral imaging to of leaves to discriminate clones. And there's a paper on that, how accurate and how reliable and how reproducible that is. I cannot vouch for, but I have seen something like that. Patrice and I decided that we'll use the latest of technologies to do what we want to do. And again, we want to understand the differences, genetic differences between clones in France and South Africa. So next generation sequencing is the technology that I'm talking about. He's going to tell you all about that. The big advantage of this is you can address the entire genome of Chenin Blanc clone, and you can do that in a totally unbiased way. You do not need any prior knowledge of the genetics at all. There are a couple of platforms. Again, I'm going to leave that to my dear colleague to give you some information about. I've mentioned some examples of the similar technology being used in other varietals, and I've listed a few here. Patrice and his group in France are working currently doing similar things for Pinot Noir and for Merlot, and I think they're pretty well underway in doing that. So we are adding Chenin now to this list. In a few other countries, similar work is being done. In Australia, on Chardonnay, where more than 1,500 markers have been used to quite reliably be able to distinguish between 15 different Chardonnay clones in Australia. And they could use that very same technology to confirm the heritage of Chardonnay as a varietal. Similarly, in California, work has been done on Zinfandel, where the Zinfandel total genome was assembled using this technology, and where they are busy resequencing 15 different clones to see what is the genetic diversity among the 15 clones of Zinfandel. Spain is running a program currently on Malbec, where they have genotyped more than 200 accessions and identified 14 clustered genotypes, which probably will be considered as clones for Malbec in Spain. So, to wrap up my introduction of our project is then simply to tell you what we decided to do and broadly how we're going to do it, and then I'm going to hand over to my colleague to give you details of progress. So like I said, early in the mid-1600s, Chenin arrived on our shores, and over that time, Chenin has had 360 odd years to accumulate these mutations under local climate conditions and environmental conditions. Likewise, in the Loire Valley and in France, similar things have happened with the Chenins in France. So our idea is to understand these genetic changes that has happened over time in the two respective regions. So if we find significant differences between clones, then it would be a very useful thing to be able to design a fairly robust and cheap technology assay to discriminate between clones in order to add some science to a clone number. Can we genetically discriminate clone 220 from 880 or something to that effect? So that was sort of the overarching aims of our project. How we went about this is obviously we need something to compare with, and that is where clone 220 comes back into the picture. So we had discussions, and quite independently we arrived at clone 220 as what we considered the most important clone currently in South Africa, similarly in France. So between us, we decided we're going to work with 220 as our what we call a reference genome. So that clone 220, we isolated DNA and we sequenced clone 220 very thoroughly to establish a baseline from which we will compare all the other clones that we will be investigating. So that was done, and it's I believe, almost finished in terms of a total high contiguous genome assembly. Then we decided that we're going to take all the registered clones in South Africa and the registered clones in France, and we're going to sequence them individually as clones. That's quite a big undertaking. That is happened. We shipped DNA from South Africa, thanks to Charles, who helped me to collect all the relevant clones at Vititech. So we collected, I isolated DNA, and we sent it off to Patrice, and they did the sequencing in Montpellier. So the next part would then be to now characterize these, to try and understand the genetic differences. And it's a very complicated picture, as he will explain to you guys now. And then finally, like I said, if we find significant, consistent, reliable differences, we can possibly design a diagnostic tool or discriminating tool to be able to identify unknown clones. And with that, I really thank you, and I need to thank a few people. I really need to thank WineTech. We came on board to sponsor the South African side of it. Anel, I saw you here. I haven't even greeted you, but thank you very much for that. And then the two Chenin associations, both in South Africa and in France, and Andre with the Old Vine Project, who are the people who supply not only moral support, but nudging all the time. How far are you? How far are you? And we are underway, I can say. Thank you very much. I'll be happy to answer questions. Madam MC, if you want us to answer the questions jointly afterwards, I'm more happy with that too.
Yes, you can decide, because you will join us on the stage, Johan.
Okay.
So you're going to remain, and then we will call up Patrice. It's as you wish. How do you? Okay, perfect. Merci. Et Patrice Tis is...
Patrice is...
Clone 220.
Okay, thanks a lot. And so, bonjour à tout le monde.
And hello, everyone. Hey.
For me to be here. Almost 30 years ago, I started to work on grape diversity. And today, I'm really happy to show you the work we have been doing with Johan on Chenin. And also, it's a real pleasure. I wanted to come to your country for a long time, and so thanks for the invitation, and so to be able to visit your really nice country. Okay, so I will show you, I mean, Johan already explained you a lot of the work we'll be doing, so I can go very fast on my introduction, but so this work is really a collaboration between INRAE, I'm researcher at the INRAE Institute, and also with people from IFV and of course with the University of Stellenbosch. And so we are member of, okay. And so we are member of three different groups working on these projects. No, okay. So as it was already mentioned earlier, I mean, Chenin Blanc is also called Steen here in South Africa, and we really wanted to work on this cultivar, and I'm sorry, I'm not sure I'm doing it right. Oh, okay. And so the objective has already been described by Johan, but really the idea was really to first analyze the diversity between the clones, and we wanted to work at the genome level, the whole genome, and so the second point was also to compare the clones between South Africa and from France, and really to understand a little bit the evolution of the clones. And our idea was to see if the clones from here are really different from the clones from the Loire Valley. And so the point is that, okay. So as Johan already mentioned, there were already many works on clones, and that's really what we will really want to do again. And so, as Johan already mentioned, the clonal variation appears after an extensive replication of this material, and you can see morphological difference. So Johan was talking about color, but there are also other types of difference. And here I will show you some some figures of Pinot. Sorry, I didn't have pictures of Chenin Blanc, but you can see here that you can see difference, for example, here on leaves, but there are also differences you can't see very well. Here you have two Pinot clones, but you can have also a difference in the ports of the plants. And as Johan already mentioned, really the differences between the clones are really due to a modification of the DNA sequence or epigenetic modification. Today, I will only talk about differences at the DNA level. And as Johan already mentioned to you, there are very different types of sequence variation. They can be very simple modification in the basis. You know probably that the genome is composed of of two letters. Actually, it's a code, and you have the letters are ATGC, and you can have modification in these sequences. You can have also what we call either deletion or insertion. So that means the DNA loses a little part of a chunk of DNA is just removed from the sequence, or you can have some addition, some insertion of DNA sequences. And you can have also bigger ones. I won't have time to explain all of it, but you have many different types of variation, and that's really what we want to analyze with the Chenin Blanc clones. Okay, so as Johan mentioned, I'm sorry, I'm just at least at the beginning, we are having the same discussion, but maybe then you will really know what we have been doing. And so the first step is really to get a very high quality reference genome. And why do we need that? It's because we know now that there are differences also at the genome level between varieties. And you can have different genes between varieties. Some varieties have more genes than others. And you can have also big structural variation between varieties. And so that's why we wanted to develop a good quality sequence of the Chenin Blanc variety. And then the second step is just to compare the sequence of the clones to the reference. Okay, so you probably, well, now it's quite known that we know how to sequence genomes. Like the human genome was probably the first one that was sequenced. And it's probably like 20 or 25 years ago when we had the first sequence of the genome. And so for grapes, the first genome was really published in 2007. And the first genome was actually something that maybe all of you would say it's not grape anymore. It was like some genetic material that was developed in France by my colleague from Colmar. And what they did, they did some selfing of Pinot Noir, and they produced like a very homogeneous, I don't think we can call it Pinot, but at least we have one of the sequence of Pinot in that Pinot Noir 40 or 24 individuals. And so that's really the first genome, reference genome. That's probably the best that we have at the moment. And so our idea was just to compare, or at least to draw the Chenin Blanc genome from, using this grape reference. And so, So the idea to analyze the genome of Chenin Blanc, so you probably know that, so the genome is in the DNA. So the idea is that the DNA is within every single cells of the plants, but we chose to use the leaves. And normally the genome is the same in every single organ of the plant. So taking leaves or any other plant material would be the same. So we chose to use leaves because it's easier to extract the DNA. So the first step is really you extract the DNA from the cells of the leaves, and then you have like a almost pure solution of DNA. And what you're doing, you just, well, I say you cut it in fragments. It's not exactly cutting, but the idea is to have long fragments of this DNA. And what you do with these long fragments, you sequence it. So it means you read the different bases that compose the genome. I will show you later on, the genome is very long. For grapes, it's about 50 million base pair. So you need to think about like a chain with 50 million small pieces that are assembled. They are not assembled into just one single molecule. But you also probably all know about chromosomes. Chromosomes are the organelles in the plants that are responsible for transmitting the DNA from one generation into the next. And so the DNA in the cells is, made of, for grapes, it's made of 19 different chromosomes. So what we are analyzing is the DNA from each of the chromosomes. Okay, so what we do, we use the reference, and then we try to, okay, so as I told you, there are chromosomes, and within one cell, like it is in in many different species, plants, animals. For example, in human, you probably know that every single cells, we have 21 pairs of chromosomes. You may have already known that. And so in grapes, I told you, we have 19 pairs of chromosomes. So for each of the pair, you have 2 copies of this DNA. And so this copy can be absolutely similar one to the other one, but it can also be different. And in grape, like in many plants and many animals, the 2 copies of the chromosomes are different. And Johan said that Chenin is the result of the cross between Savagnin and Sauvignonas. So Chenin received 1 chromosome for each of the 19 pairs of chromosomes in the Chenin genome. 1 chromosome came from the mother, and 1 chromosome came from the father. And so you have 19 pairs, but they are different one from each other. So one very difficult task when you do the sequencing is to try to separate both copies of the DNA of each chromosome. And so that, because they are different, but not that many, and you will see some of the slides I will showing you, they are not so easy to differentiate. But we can do it. It's sometimes, I don't know. Okay, so what we try to do is using the reference sequence, because the DNA from Pinot and the DNA from Chenin are not so different. We can see regions that are very similar and that can help us to align the DNA into the chromosome. And so we align each of the copy of each chromosome. And so we can have what we call different haplotypes. And so there are 2 haplotypes for each of the chromosomes. And so here, as I can show you, you can I mean, make maps and using, so when you do the sequencing, you actually have fragments that are designed just randomly. And so some of them are exactly the same, and some just have some, I mean, some part of the fragment that you sequence that are similar. And using these parts, you can really align and make the whole sequence of one single chromosome. And then you can then look for the differences between the haplotypes, because there are differences. And so that's the first step. Once you have the genome, the reference genome, then you can use this reference to analyze the clone genome. And so, again, it's the same. What you're doing DNA extraction. So you have, I mean, DNA from each of your different clones. And again, you sequence it. But this time, we are using a different strategy, as Johan mentioned, and we are sequencing very short fragments. For the reference genome, the mean size of the sequence that we are analyzing is around 20,000 base pair. Here, in this part, the fragments are about 150 base pair, which is very short. But there are a lot of them, and so we can really align them. As we did for the reference, we can really align the short references on the reference. And then once we have that, we can compare the clones by looking at each of the individual bases. And so here, for example, I showed an example where you have one single modification, A, that was modified into a T in one of the clones. And so that's what we are really going to do. And so the idea is then using these differences, we will try to compare the different clones that we have been using in the analysis. Like, for example, what was done here on Chardonnay clones, where they tried to see if there were differences between the clones. And actually, you can see that, for example, this group of clones are very different from the other. And that's really what we want to see for the Chenin Blanc clones. Okay, so in terms of results, so here is what we got for the reference genome. I know it's quite difficult to understand these slides, but just let me show you a little bit. So here on one side, you have one, what I call haplotype, so the sequence of one chromosome. On the other one, you have the second haplotype, so the other chromosome of the pair. And so here, each line here represents one chromosome. So you have the 19 chromosome of the genome on one haplotype, and the other haplotype is here. And here, each line here represents the sequence, the whole assembled sequence of each chromosome. And in some times, we were able to have only one big molecules for one chromosome. In other, we were not able to have only one, and we have a few numbers. And here I'll show you, sorry, I'll show you the results. So you have, in this table, you have each of the 19 chromosomes. You have the number of sequences that we were able to assemble for each of the chromosomes. So it goes from 1. I mean, in many, we have just 1 sequence. In some, we have 3 different sequences that we were not able to assemble into 1 single chromosome. But here, you have the size of the genome. And as I told you, the whole size of the genome is around 500 million base pair. And in our analysis, that's about what we have. And you can see also in this slide that there is a small difference in size between the two haplotypes. And here I just show you a comparison of the genome for Pinot Noir, so the first reference, and those are the black lines. And then you have the size of the two haplotypes for each of the chromosomes. So you have the 19 chromosome, and here you have the size in base pair for each of the chromosomes. And you can see that there are small differences between the haplotypes, and there is also a big one here between in chromosome 7, and I will come back a little bit later on. So here is, so I told you there are 500 million base pairs. So I cannot show you the whole genome in base pair. It's look like if you would be writing it, I think it would take I don't really remember exactly how much, but just by writing it on a paper, you would probably go from the Earth to the Moon, just writing these 500 million base pairs. So I cannot show you that. But here you have like a small scales where you have, so again, it's a comparison between Pinot Noir sequence and the Chenin Blanc sequence. And so here you can see that a position in one chromosome of Pinot and the same position in a chromosome of Chenin are very similar because you have really very well aligned both sequences. There are a few differences. And here you see again the difference I was showing you earlier on chromosome 7. And for example, here you have, so chromosome 7 is here. So most of the sequence is similar, but here on the Pinot Noir genome, you have a small piece of the chromosome 7 of chromosome 7 of Chenin that is in another chromosome. So that means our sequence is good, but it still needs a little bit of work to check some of these points. And also, here you see it very clean, but if you, I'm not sure I will be able to show, yeah, and so here, for example, it's also the same, but the comparison between both haplotypes of Chenin Blanc. And again, you have a very good alignment of the two pieces of DNA. Okay, so I just wanted to show you here. So the first slide I was showing you was almost perfect and very good alignment. Here you can see that there are everywhere in the genomes what we call repeated sequence. So there are sequences that are very similar, and they are repeated hundreds or million times. And if you don't use the right algorithm to do the alignment, you can't really separate them. And so here you can see that there are lots of repeated sequence, but we can remove them to have a very nice, clean picture of the genome. Okay, and so that's actually where we are now in the sequence of Chenin Blanc. So I guess we have been doing quite good works, and we're now really in the process of comparing the Chenin Blanc clones. And as Johan mentioned, we have been sequencing 12 South African clones and 14 French clones. And so we are, okay. So here you have, again, the different materials well, I'm not sure the name of this color. In this salmon color, you have the clones that are the same between France and South Africa. And in green, you have a clone specific to South Africa. In blue, the one specific to France. And so we have been sequencing all this material. Some of them didn't really work, and so they are the one that I highlighted in red, and we will have to reduce the sequence. Sometimes it's working, sometimes it's not working. And as you can probably see also here, you have the number of bases that we have been able to read in the sequences. And as you can probably see, and I have highlighted some things, you have some sequences that work very well. Here we have 35 billion. We were able to read 45 billion of base pair, which means if we have like 50 million base pair for one single genome, we were able to read almost, that would mean almost the equivalent of 50 genomes. But we have some also that were not as well covered. And for example, we have some clones where we have only 3 billion of sequence, but it's still, I think, sufficient for what we want to do. And that is actually what we will be doing now. So here are the ones that are much less covered, but still 3 billion base pair still represent about 6 to 10 coverage of the whole genome. And so I guess we are here. And so now what's the perspective of this work? So first of all, we need to finish to clean up really the reference genome to be able to really have a very clean one. And also, we want to also compare the sequence of both haplotypes, of both pairs of all the pairs of chromosome, and see if there are differences in genes or in other types of variation. We also, as I told you, in some cultivar, you have specific genes, and so we also need to annotate, to find within the sequence, because the 500 million base pair does not correspond to genes. Genes only represent a small portion of this genome. And what we need to do is really look for the genes. And then, of course, identify the variation and compare the clones. Actually, yesterday, we received a mail from our colleagues from Montpellier, and actually, the analysis of the clones is finished, and so now we need to look at the sequences, and I cannot show you it today, but I hope we'll be able to show you this data pretty soon. Okay, so, and to finish, I want to thank, of course, the funding agencies and INRAE and IFB, because we are I mean, paid by this, and also the Chenin Blanc Association for providing also some support. And Stellenbosch University, of course. And then just also, I want to acknowledge the works of my colleagues, and especially of Valérie Locou. Valérie is in the room over there, and so you can also talk with her. And so Valérie, Catherine, and Gauthier were very important in the analysis of this material. And with that, I'm finished. And so thanks for your attention.
Merci, Patrice. Restez avec nous. So in terms of questions and timing, we have a very interactive Congress, and we have some time when we're going to take the pause and lunch, and we have organized it in such a way so that there's a lot of exchange for questions and to speak a little bit further about this. Thank you very much. I'm going to call Virginie. I also need glasses. Virginie Grondin, who is going to talk about. Bonjour Virginie, venez avec nous. You're going to do an intervention on the dealing with disease, hybridizing varieties to be resistant, mold resistant, to specifically mildew and odium. Merci beaucoup.
Bonjour. Bonjour. Alors,
hello. I'm going to speak in French, and it's going to be in two parts. First of all, I'm going to speak about the Chenin Conservatory, which was carried out in France and in South Africa. Then I'm going to talk about our program of varietal program. So just to remind you what happened on this program, in 2015, there was the Day of Chenin, which happened in Anjou, and there were Patrice and others. That allowed us to take stock of the conservation of the. So we talked about two aspects, and the importance of keeping the heritage, and also not only that, but to enrich it. So there we are. So we started from 2016 for the program to conserve the existing heritage in France. We took stock. We saw that there were several conservatories in Val-de-Loire and also elsewhere, and that they were in danger because they hadn't aged well. So we started with new plots. And the first thing was to save what we found in the southwest of France. There was a little area, and the viticulturist, he was leaving to go on pension, and so my colleagues from the southwest went to take some of these plants, and then whatever was healthy, we have. So now they took it. So we have 12 concessionary areas. And then we took out the various. So there were 230 accessions, different, and we. here. So we put that into new plots. And then, so then we had prospection campaigns in 2016, 2017, and it was, in 2017, we were mainly working in Anjou, and we saw that there were 230 new accessions. And so when we do prospecting, we go to the old plots of the vine and we look for whatever's different. So we want to have the maximum of genetic variety. And so we also work on, we are very productive types, and also we look at the maturity, everything. So we also you always see it through the filter of future production and also to maintain the diversity. And then in 2019, with Thierry Lacombe, we came to South Africa so we said, well, there's a lot of Chenin in South Africa. Maybe we can also find different Chenins and then to bring them back and into this conservation area. And so we came in February 2019, and I'd like to just take the occasion to thank all those like Van Teck and Shah and Ina, all these people who allowed us to have such an excellent stay, and we took back 15. We looked at 15 different plots, and we saw 97 labeled strains. And after the 15 plots were surveyed. And then we waited for the full health tests on the labeled strains to see if we could use them in France, because obviously we didn't want any sort of viruses to be introduced to France. So if we can get this slide, I can present you with the results of these tests. In October 2019, Charles was very courageous to have a look at all the various strains that we collected, and and so I think it was really courageous to have to find all of those, because we didn't have very precise data at the time. So it was quite a challenge to collect all the strains. These are some of the strains from South Africa, and of these strains, 72 were positive, which were positive for R3 plus, R3, and we couldn't take vegetable material which had any problems. So we kept 24 accessions. We did some additional tests, and so we found that we have 10 accessions free, and so they could be sent to France for quarantining. We kept 14 other accessions. We had perhaps what we consider a secondary virus in France, and we wanted to try and so we also brought them in under quarantine. And at the end of the day of the 24, 4 were not retained because they had viruses complementary to R2. So they could have contaminated our strains as well. And then in February 2022, I've spoken about the quarantine. So there are 3 years of quarantine. So, and in 2020 February, the first accessions were able to come out of quarantine, and so there were 17 strains which were retained. Well, listen, at least half of the strains. There's also going to be a second batch, which are going to be come out of quarantine in February 2023, and we keep that at our hub, where we keep the plant material. I also wanted to say that in 2021, I've got a colleague who does prospecting for other varietals, and when he was looking around, he found two different Chenins in that plot. So we're bringing that from Isère to Angoulême, where we've got our hub. And just before I come, I had the confirmation that we are busy planting 22 accessions, and there's a reclamation of the Chenin Rose of South African origin, which is actually under progress at the moment. So what we've got in our conservatory is actually originally from South Africa. And as I was explaining to you, the first plantings on the prospections, which we did in South Africa, are going to happen in 2023 and 2024, where those that come out of quarantine next year. And this plot will act as a resource plot for characterizing the phenotypic diversity. So in 2 days, I'm going to we'll speak. You'll hear about the study of intravarietal diversity in the context of climate change. And also, there's a possibility of new selection programs for clones representing the full range of behavioral diversity. This conservatory can also be useful for disseminating the material for the vine biodiversity. So in other words, plant material from the entire conservatory, and that will allow us to have a high diversity of phenotypes, as well as the health guarantee against regulated viruses. We hope that the conservatory will be enriched over time by new surveys in other French wine-growing areas, like happened with the case of Isère, and also abroad. So all my colleagues are aware that there's this conservatory of the Chenin, which needs to be enriched, and so maybe on the island of Île-à-Rond, on the Atlantic coast, and why not abroad? Now, securing the conservatory is terribly important. So we are busy discussing with the winemakers of Vouvray to have a duplicate conservatory, just in case something should happen to ours. And, there could be a climatic accident or something like that. So it's best to have a second place where we can conserve these types. And so this new Chenin Conservatory is thus a testimony to the biological evolution of this variety over the years and also between the various vineyards. It's one of the future sources for adapting to changing production conditions. As I've noted, that is one of the solutions. We're also talking about this conservation programs. And we also want to have a second program on varietal creation to create varieties which are resistant to mildew and odium based on the Chenin grape variety. And just to remind you, either I'm speaking too fast or the computer's too slow. I wanted to show you the previous slide. But anyway, so to explain that plant breeding isn't something very new, because from time immemorial there have been two types of innovation. First of all, there was the unconscious innovation, and so that means that, you know, from a wild vineyard we domesticated it, and we arrived at our present cultivars. But then also you have conscious innovation, which is creating, and then the most eloquent example is South Africa. That's, in other words, the Pinotage in South Africa, the crossing between the Pinot Noir and the Hermitage, or the Cinsault, as we call it today. So that is conscious, a very good example of conscious innovation in 1925. Why do we have to have resistant varieties? So, well, we have to control the main vine pathogens like mildew, powdery mildew, and there's pressure from society. We have to protect the health of the operators, well, and also the plants, protect the environment, and then improve the competitiveness of companies. So in order to reduce the production costs, and it's an opportunity to create new products. Where do the sources of resistance come from? Well, the vitis of American origin and Asian origin they bring the biotic and abiotic resistances. There's also muscadine, which, as somebody with whom I work, is a cousin of the vine, and there we can also look for sources of resistance to those diseases. In France, it was decided, certainly amongst all the professions, that we should create something which is resistant, but also should be iconic, emblematic of their resistance. Oh dear. So it's what we call absorption crossings, where you have the family resemblance, and we work on that program in the Valley of the Loire with the Melon, Chenin, and Sauvignon. So that's a program which was requested by what we call the interprofessional organization, and we actually are carrying out that program. I'm so sorry, I've got a technical issue here. So there's the regional variety creation program. What do we want to do is to create resistant varieties from the emblematic, iconic grape varieties of the Loire Valley. So it's a partnership which is of the Loire. And there's also the IFV and INRA creation. They are doing the creation and selection, financed by Interloire. So what are we doing? We're crossing the Melon, Sauvignon, and Chenin with resistant geneticists from the Resto and Genovina programs. And that's being carried out in 3 different places. There's in the IFV, there's in Gros du Roi, in Colmar, you have the INRA, and then Montreuil, Belay for the IFV program. So there you have the 3 various areas in the 3 corners of France. I'm going to show you how we work outside the laboratory. We've got a special process for castrating the plant. There you can see just before the flowering, we're going to pinch the flower. So you can see on the top photo, you can see there's you see only the pistils on the bottom one. So that is the castration step. And then that's on the Chenin. And then we're going to pollinize. We're going to play at being bees. And we're going to get the resistant type of pollination. We are going to then we bring along the pollen to the castrated plant. We have a little bag which we place underneath so that we don't get any external contamination. So we do this for 9 days in a row on all the bunches which have been castrated, and we pollinate them like that. And then we hope that the work has been properly done, and we wait and see what the 3rd stage is. Well, it's rather, it's pretty stressful, but if everything goes well, then we have a nice bunch, which means that if there are grapes, that means that we succeeded in doing our pollination. Then we're going to put a net over it. We don't want to lose the pips. So that year I found 544 pips, which are then sent. I sent them to the IFV at the Gros du Roi, and they're going to then do the rest. Well, they're going to germinate those pips. And then they're going to have a genetic analysis, and they're going to have a selection by markers to see where are the little pips are, and they so if they have with the assisted selection, if they're going to have the parents, and so over 2 years of pollination, we're able to have 2,942 Chenin pips, and we only kept 6 little offspring, little plants. And so, well, we lost a lot en route, but at least we've got 116 which have the resistant markers, resistant to odium. And then on those 116 descendants, we actually, the initial objective was 80, so we saw that actually we'd done a good job. And then we had to sort them out and see what we were keeping. And we said, well, we're first going to sort them out first time. And for that plot, we needed 5 or 6 little plants. If we have one from that result, then that's also fine. So we try to keep a certain number of individual plants which are more or less balanced between the various sources of resistance. Don't forget we had different parents. We took different resistant parents with different sources of resistance, and then we made a choice to spread them out according to various combinations. So you see there you've got 3 different combinations of resistant sources, and so that's more or less how we spread them out. And the plants were then grafted, 10 little plants according to the descendants. We planted them in July, and we have a very big plot. In green, you see the 83 Chenin descendants, and also 83 descendants of Melon and 83 of Sauvignon. So we we had a reference point, of course. And then what do you do after that? Well, we have to wait until this little plant planted in 2021, and by 2024 we should have the first follow-up, what we call stage 2. So we have 240 genotypes, so that's 5 vines and the genotypes. And so we're going to do phenological follow-ups. So at ripening, at veraison, we're going to see what the situation is, to see whether they're still resistant to mildew and odium. And then follow up also on the harvesting. We do that various strain by strain. And then micro vinification. We're going to have 240 genotypes which are going to be vinified by my colleagues. Then, from 2024, we go after 3 years of follow-up, we're going to see what the results are. And then we're going to plant the new plots. Instead of having 5 vines per genotype, we will have only 20 genotypes on 2 different sites. And within 15, 20 years, we hope to be able to have these new catalogues registered in our catalogue, which are therefore resistant to those various illnesses. So I said we've got 240 genotypes. How do we decide that genotype A is more interesting for us than genotype B? So for that, we need to have certain ways of deciding. And first of all, we're going to integrate the knowledge on the impact of climate change. We've got the big project in France called La Cave, which has given us lots of information on the choices, the loss of acidity, the sugar content, the risk of frosts, and all, there are various factors which have to be then incorporated, and for a global regional reflection to know what product is good for industry of tomorrow, and who also will be tomorrow's consumer. We have to think about what could happen in 10 to 15 years. So all that has to be taken into consideration. And what is important is that what we call the interprofession helps us to. So we have to define an ideotype. That would, in other words, the ideal strain, the ideal cultivar, rather. And that's a decision taken by all the professionals in the production area, wine growers, the nurserymen, traders, and so forth. And all these information are going to allow us to direct our selection of the offspring according to these predefined ideotypes. So, in conclusion, the varietal creations, that's one of the recent varieties are one of the answers to reducing the use of fungicides. As I said, the aim of this regional breeding program is to obtain new varieties close to the iconic parent in terms of behavior, whether it's agronomic, or sensory, and so on, and also that carry the resistance of the other parent. So since 2018, we've been crossing and sorting and grafting, planting the progeny in an experimental plot, and from 2024 to 2027, for 3 years, we're going to have the intermediate selection by studying the 240 new varieties, and choose a variety to be retained for the final selection, which will be, the final selection then is between 2028 2033. We're going to plant two big plots and characterize the 20 or so new varieties selected. And then we will see what varieties are going to be selected definitively. 2034, finally, we can register these 2, 3, or 4 new varieties in the catalogue and classify the selected varieties. We can start distributing them. So you see, it's a long job. But we'll see you in 2028 for the intermediate selection to explain what we selected of the various individuals. I thank you very much.
Merci Virginie. C'était compliqué avec le...
It was a bit complicated with the changing of... Alors...
Yeah, I'm going to call Patrick. The technical team for the diapo. So, Virginie, merci beaucoup. Oui, vous pouvez poser le... C'est un travail.
So thank you very much. It's extraordinary work that you've carried out. Of course, long-term work.
Absolutely incredible. Thank you, Professor Johan, Patrice, and Virginie. And maybe now a winemaker's perspective on the future of Chenin Blanc. And I'd like to call Patrick Baudouin from Domaine Baudouin, but also from the Académie du Chenin Blanc, pour nous donner sa perspective, la perspective d'un vigneron. And also the impact, of course, of everything that we spoke about for the future of Chenin Blanc.
Si, ça a l'air de marcher. Bonjour à vous tous.
Hello, everyone. Thank you very much for welcoming us here, and in particular, Ina. We have just listened to some scientific presentations, and Johannes talked about, in fact, he referred to a discussion from last night and to tell us how it's all happening. And I was listening to that, Johan, and to what you were saying. And also with Evelyn, just now, we were saying to each other, when I suggested to have a study trip in 2015 on Chenin, the Chenin Blanc, and then when we created the Academy of Chenin with Angers, and we organized the Congress, etc., to which many of you came. In fact, I really didn't think that one day we would be able to contribute in one way or another and to launch such a scientific project. So it means that we are actually a little bit touched and a bit proud. Thank you very much. And at the same time, in fact, I don't have any scientific training, which makes it possible for me to understand everything. So it does, comfort us, if you like, that we need to work together, and that we all need each other, including for the final product. Because in the long run, in fact, scientists are working, yes, and winemakers are making wine. The consumers drink it, and we are all three parts. We are all consumers, and. Right, so I don't manage PowerPoints very well, so I'm going to try and be clear. Right, I need to aim it somewhere. Yes, you have to aim it to the back.
Non, mais on va essayer. Voilà, quoi. Donc voilà, c'est le titre. Donc voilà.
Right, so what are the challenges for Chenin? And I'm going to talk from the point of view of a winemaker and so it's a revealer of place in terms of climate change and genetics, and I'm going to also talk about research as well. So, to start out from a philosophical point of view, and I'm also going to refer to Rabelais, science without conscience is the ruin of the soul. He wrote in 1532. He's a writer from the Val de Loire in Touraine, who is known for having first used the word Chenin in a book about a healing wine. And in fact, we don't know that the word Chenin was actually talking about this particular variety that we are talking about today. I'm not sure about that, Johan. But of course, that's part of the mystery, isn't it? And that remains to be discovered in the future. Now, right, so the different varieties. It's somebody you know all well, I think. Many of you. He is not with us today. I think he's in Mexico somewhere at a congress there. But he supported us in understanding the Chenin grape variety, because this variety, which was of a Euro-Asian species, Vitis vinifera, was voted on in Angers in 1870, and which was among 50 different names, according to the dates, provinces, and places. The name Chenin was then given. So I have to aim. Okay, we can stop here then. So Jean-Michel Boursicot gave the title of one of his conferences, and in fact you can go to YouTube for that, which is really worth seeing, where he talked about the odyssey of grape varieties, which many called few chosen. And the issue I would like to discuss with you today is twofold. So it's the Odyssey, which is an extraordinary journey, but in the end, Odyssey or Ulysses returns to Ithaca and he exterminates all the suitors. Now, even if the circumstances around his death are debatable, he does end his days with Penelope without going back to listen to the sirens. So, in fact, Vitis vinifera varieties on the Eurasian continent have known a real odyssey. But do they also have an Ithaca? Where does it end in actual fact? Because we know the two main ports that have welcomed Chenin, it's the Loire Valley and South Africa. But has the journey ended? And what are the mermaids? What are these mermaids of Vitis vinifera? And then many called, said, who chose these varieties? And so how was it chosen? In the 1930s, a Soviet scientist, Nikolai Vavilov, invented a new science. He called it ethnobotany, and it links the study of plant movements on the planet with genetics and ethnology. This current, which is called human geography, includes amongst its representatives in France a geographer called Roger Dion, who published a history of the vine and wine in France in 1959. And here he shows that the distribution of the vines and their varieties at a given time in geographical areas is a conjunction of geographical, geological, and commercial factors and the know-how of the wine growers, each of these factors being essential to the success and durability of a vineyard. And terroir and wine are actually intertwined. They go across the Eurasian continent and across the world. Historians know very well that a grape variety today, which is considered to be iconic for a region of an appellation, has often only been so for a few generations. So some examples, when we talk about the grape variety on the right bank of the Garonne, from Blaye to Côte-de-France, passing through Saint-Émilion, was not Merlot 100 years ago, because there were in fact many white grape varieties, in particular Sémillon and also Cabernet Franc and other red grape varieties. The nomadic nature of grape varieties was also dependent on people. So the theme of this congress is revealer of places. So in fact, Chenin exists for a long time, or wines do. And in Rome, wine connoisseurs demanded that the origin of highly sought-after wines be guaranteed by a stamp or on the amphora, such as Falerna wines, which were sweet wines. So in France, 90% of Chenin is now concentrated in the segment of the Loire Valley, from Touraine to Anjou, from Vouvray, Montlouis, to the surrounds of Angers. So the question, of course, that we are asking, and I've asked myself this question many times, and that we are still debating today, why? Years of work on this issue have led me to the following point of view, which is set out at greater length in my text, and you can find, which I called rather, Controlling the Temptation of Botrytis, the Problem of the Anjou Wine Growers. We now know the probable parents of Chenin, which was, of course, referred to the Chenin Congress in Angers in 2019 on Savagnin and Sauvignonas, but we do not know the date and place at all. It can be found in many vineyards in France, in microsurfaces when it arrived, or when it left, or where it went. We don't know at all. It traveled at a certain time and stopped, and why is that? To sum up, in fact, the human species, this is my opinion, of course, has a high physiological need for sugar, and for centuries wines were acidic and naturally low in sugar, except for a few rare and expensive wines. In this part of the Loire, the Chenin found the soil, the alternating humidity, wind and sun, allowing it by its specific nature to merge with a fungus that generally causes agricultural disasters through ignoble rot to create what we have actually called noble rot. And it's an oxymoron, as it were, because it has produced deliciously sweet and rare wines, and therefore with a possibility of being reproduced. So Chenin has another very rare characteristic that can be a real factor of adaptive success, which is its versatility. It can produce fine wines with a wide variety of expressions and nuances. Nuances of the terroir, that is, by dry whites as well as sweet wines, something that very few other grape varieties can do. So here is a real story of a Vitis vinifera variety. So this variety has probably traveled through time and space for many years, for centuries probably, and has stopped where it has merged with a place, human tastes, and a niche market. Then I would like to talk about, well, with apprehension, of course, because I'm not a scientist at all. It's, of course, a subject that we have to talk carefully about. So we need to talk about a classification which can really be a bit confusing as well. So I don't know what you were going to say, of course, but botanists have indeed defined a family, which is called the Vitaceae, which comprises one genus, Vitis, itself divided into two subgenera. Right, I need to move the slides on. I'm sorry, I've actually missed some slides, but it's not serious. There we're talking about the Savignons and the Sauvianas. I don't manage as well at all, just like Virginie, in fact. Help. So, two subgenera. The first one, Muscadina, which we found in the North American continent, and its Muscadina grapes have varying degrees of foxiness, if you like, which is between wild strawberries and crushed bug, or strong black currant aromas. But beware, because here is a catch. The second subgenus was called Vitis, which is the same name as its genus, which in the course of the tertiary period, millions of years, gave rise to several species, including the Euro-Asian species Vitis vinifera, which was listed as such by the botanist Carl Linnaeus in 1775. So this particular species is the one that has been producing our wines of expressions of place for centuries and includes from different crossings. Now, here we need to make a link between appellations, of course, are controlled by France, and this it was in Portugal, in fact, that the origin of a wine was guaranteed by law starting in 1756. In France, the creation of the Comité National des Appellations d'Origine in 1935 was intended to enable the consumer to distinguish easily between appellations that cover quality wines, called fine wines, and those that apply only to ordinary wines. And this is a quotation by Capus in 1947. The regulatory basis of the appellation in 1935 is based on a triptych, which is the soil, delimitation, then the grape variety, as well as the quality of production practices. It is here about creating a legally protected category called fine wines, expressing their place, their terroir, by making it possible to develop them by protecting them from, and I quote again, unfair competition from ordinary wines. End of quotation. In 1935, the definition of the criteria for AOC wines excluded interspecific hybrids obtained by crossing Vitis vinifera with American Vitis. And this was done to find a defense against phylloxera, and which also brought, depending on the plants obtained, resistance to cryptogams, and especially mildew and powdery mildew. The grafting solution at that time focused on the fight against phylloxera by grafting Vitis vinifera onto American species, which did not provide resistance to cryptogams. This is then obtained through the use of various treatment products, in particular from the 1916 onwards through synthetics chemistry. Now, an interspecific hybrid cannot scientifically be called a grape variety, whatever the proportions of their genomes obtained between the American or Asian species and the Vitis vinifera, according to the law of genetics. There are new interspecific hybrid varieties which are different from the Vitis vinifera grape varieties. What motivated the rejection of hybrids at the time was in particular the fact that the wines produced had so-called, as I mentioned, foxy or aromas and flavors. So it was animal, varietal, power, and the smell of wild strawberries to that of crushed bugs, and very astringent tannins. And these species were criticized for not expressing their place of origin, if you like, but thus gustatory diversity, but for making their expression of plants predominate, which erases the expression of origin or place. From then on, from the point of view of amphilographic science, the term grape variety refers only to the cultivars of Vitis vinifera, excluding interspecific hybrids. So by law, before 2022, the AOC wines, terroir wines, local wines, and fine wines had to be exclusively from Vitis vinifera. So our Chenin Blanc, which was named, that you in fact named in South Africa as Steen, in South Africa before it was named Chenin in Anjou, is therefore a grape variety that is particular, of a particular species, Vitis vinifera, and itself a subgenus of the genus Vitis. Now, the link between the Chenin and fine wines, beg pardon, so I need to move on again. It is one of the surprises, the discoveries by historians when we prepared the first Congress of Chenin, that in 1804, the survey requested by the Prefect Chaptal on grape varieties in France gave the following result for Maine and Loire, which is a former province of Anjou. Now, number one, Franc Pinot. So it's the white Pinot, or called Franc Pinot, which is called Chenin around Saumur. And it is the only good grape variety cultivated in this department, and it represents the bulk of our vineyards. In 1804, the AOC, the concept of terroir did not yet exist, but the description given by the rapporteur of the inquiry, Merlet de la Boulay, president of the Agricultural Society of Angers, says that the only good one out of 10 grape varieties listed already, in fact, corresponds to a search for the identification of fine wine according to place. So Chenin is no longer a major variety in the Loire Valley, but in Anjou it represents around 20%. But it is the grape variety of the fine white wines of Anjou, of the appellations of great terroir wines such as Savenière, Quart de Chaume of the Coteaux de Léon, or the Cru in White Anjou, etc. But when we talk about the fine wines in the Loire Valley. So what has taken place in the meantime is that there's climate change which has had an impact on the grape variety, and it's of course on wine growing. So another factor that should make us act is the growing demand from society for a change in humanity's relationship with its ecosystem. So for vineyards, a hot topic is the use of pesticides, and finally this question of place of wine in consumption arises as well. So what is the resilience of the Chenin grape variety? Will it be able to continue to produce the fine wine that express our terroir in its versatility in the relatively short term? That is the question to ask. And of course, climate change has particular impacts. Working with the soil, we don't always, or tillage is changing. there's a real impact on the soil and the work that is carried out by wine growers. And this is also noticeable in the fact that there are few winters, there's rapid warming, there's drought, and these, of course, we also talk about eco-pastures, pasturing. So we are looking for other methods in which we can counter this the climate change impacts. So, in fact, has a default or a fault. It's one of the earliest grape varieties, and with climate change that is bringing warmer winters and also an increase in early temperatures. So it's the evolution or the development. It's in fact a document that was provided to me, and we can see here that we have so the period of frost. There is, as I mentioned, also rapid warming, and we have therefore early bud break, which is followed by a descent of cold air or less cold air in Europe with the spring frosts that we used to know before. So these explanations, scientific explanations, are giving with regard to the dropping of the cold air. Now, in this regard, what do we do? And especially when it's a grape that is budding early. So I'm going to also be talking about, we've tried to, so we are leaving a lot more wood, meaning that if we believe that we can go ahead and we cut and we hope, therefore, that we are not depleting the vine too much. And then this year, we didn't have frost. Was it because of that? We don't really know, because we need to experiment this over a number of years. There are a lot of other parameters as well. There's drought, and of course, all of these factors we need to take into account, and we need to improve our techniques. So with regard, my wine estate, and we're refusing techniques that we call where we use a lot of hydrocarbons and also contributes to climate change, obviously. So we are trying to find other solutions to warm up, to heat, and to consume less electricity, etc., and of course diesel as well. So we have water stress, and no, it's not that. So the soils of our vineyards and the Armorican bedrock, the soils are filtering with a very low useful water reserve. And in September, in fact, we only had 350 millimeters of water since the beginning of the year, with only the 50 mils that we had in September actually shaved the Chenin, but we had low yields. So in response, since 2017, we decided to plant in 2 stages. So this is a little video, I think, or the pictures. It's not actually moving. And the rootstock first, we planted 101.14 Riparia rupestris and 110 Richter. Ooh. Was that me? I'm not a terrorist, I'm a terroiriste. So, right. Of course, normally we go a lot deeper with this rootstock structure, and with the grafting, the Massal de Chenin 3 or 4 years later. But the objective here is we want to work on the construction of the stock together with production. So these are the results of the analysis on the roots between the 2 methods of plantation, or planting methods, if you like. So what we can note here is that better rooting when we do that. Now, another effect from climate change is that the versatility of the expression of Chenin is affected, and that's one of its characteristics, isn't it? Because for the last 3 years at the domain, we have not made sweet wines because we've had frost, unfavorable late seasons, and in terms of noble rot, botrytis needs particular conditions, humidity and not drought. We also don't need violent rain or heat and coolness. So these extremes, these are all contradictions. So this is what we call the gentleness, if you like. So the excesses seem to be less favorable to the versatile nature of the Chenin. And part of our response is therefore to increase our volumes of dry Chenin, and this has a direct impact on our markets. So the expression, structural expression, with regard to the structural expression is that it is not very aromatic. It's a structure that in the mouth, it is acidity, there's a freshness, and that is a characteristic of Chenins at the limit of their maturation, which makes them wines for gastronomy, for aging, that can be kept, but that have more on the palate than a nose. With the rise in temperatures, the early harvests, we have a higher rise in degrees, a drop in acidity, a rise in pH, and therefore a potential change again of our wines on the markets. And part of our search for an answer lies in the evolution of our vineyard management to modify the pruning, to reduce the total leaf surface, to abandon leaf thinning, and to think about an experiment in terms of agroforestry. But this is no doubt insufficient. So we need to find various research opportunities. And in this regard, the INRA has been pursuing research for a number of years, since 2017, in fact, in terms of plant cultivation. So here it's about obtaining new interspecific hybrids between Muscadina and several emblematic French grape varieties, including Chenin. And after several back crosses, new plants were selected that have retained the Muscadina resistance genes, mainly against mildew and powdery mildew. And this seems quite problematic to me, in fact. And irrespective of the admiration that I have, of course, for this work, it's problematic because it's recognized today that these new plants cannot be genetically recognized as vinifera, and it was therefore necessary to change the status of AOC in France. But of course, that's not the most worrying part here, because no one can say here that there will not be resistance, bypasses to resistance, especially for downy mildew, which has reproduction. So we need to invest to create a single new hybrid that adopts this approach to prevent further loss of diversity in the vineyard. And it should be remembered that 10% of grape varieties currently provide 70% of the wines. So the loss of diversity in the supply of plants for wine growers can take place. Of course, there are also other diseases, a decline or disappearance, some of which are emerging. There's flavolence, and that threatens the sustainability of the vines. We have climate changes, drought, heat stress, frost, which raise many more questions about the sustainability of the vineyard. And then the taste of wines obtained by hybridization remains marked at different intensities, of course, because there are a number of characteristics of Muscadini which lacks finesse. And we are no longer dealing with wines that express the place, with terroir wines corresponding to the original definition of the AOCs, where we talked about fine wines and ordinary wines. The ordinary wines marked by dominant aroma and inelegant structure in the mouth, no longer expressing the diversity of place. So in fact, many of us producers of the terroir believe that this pathway, in fact, including the next step of varietal creation, beg your pardon, does not meet the quality criteria for terroir wines. We are perhaps, I don't know, acting more like the mermaids of this odyssey that we've undertaken, and therefore many wine growers would like to see other directions favored by research, including financial ones, so that experiments can be led. So one of the guiding principles is to challenge the intensive monoculture model of vine growing on several levels. One would need to explore the tremendous reservoir of underutilized genetic diversity and to also work together on the diversity of rootstocks and to work on the diversity of the rootstocks, which is completely underexploited today and provides a fundamental link for the durability and reliability of grass-seed Vitis vinifera in the context of climate change. Work is currently also underway research and work carried in Bordeaux by INRA under the direction of Nathalie Hollard and Vidadapt and Greffadapt, etc., and Anjou. So there's also research that is carried out with large budgets on biocontrol products, on plants, on vine diseases, and then changes in driving patterns to reduce photosynthesis, to promote the natural defense mechanisms of Vitis vinifera varieties, to use the resistance or tolerance genes naturally present in Vitis vinifera, agroforestry and eco-grazing, etc. In my opinion, research must not favor solutions for volume wines, leaving local wines to be marginalized and eventually disappear. This would be really bad for French wine and for all fine wines. As Jean-Robert Pitt wrote, he's the chairperson of the Geographical Society, who said, as soon as the working classes drink less and less wine, the vineyards of everyday consumption are doomed to disappear. So we have to ask ourselves this question about consumption and evolution and development. So official initiatives in Anjou and the Loire are also exploring these avenues, but they are fragile. So we, under the guidance of Virginie Grandin, they provide wine growers with more than 100 different Chenins. In fact, we really underestimate the work that these organizations are carrying out. This conservatory, in fact, under the direction of Virginie Grandin. And we also are talking about the testing of other varietals. And the procedure for us seems to be, honest, it seems quite heavy and cumbersome. Now, you might ask, what about Chenin and all of this? Do we keep it? Of course, it's a real question. We are here in your country, in South Africa, where Chenin lives and produces in different conditions than in France, with fine wines, expressing terroir, and it's a hope, because you've shown in 2019 in Angers. But we will only be able to keep the Chenin revealing places if we change the model. We have to change the model. If we change the model, we need to adopt another vision of our relationship with nature and also have certain objectives and research studies and scientific research that contributes to this new vision. We must get out of this kind of technological headlong rush that relies only on a few poorly controlled parameters with excessive funding to maintain the illusion that man is master and possessor of nature. We need to come back to humility. We do not need to replace thousands of years of co-evolution with laboratory manipulations. Without a comprehensive understanding of the interactions of the living, we cannot make the Chenin develop. So to conclude, I'm sure I was far too long. Do you know that at a time when in France considerable sums are being invested in the creation of a few interspecific hybrids whose viability, durability and taste potential are not at all foreseen, in fact there is a lack of will and means to save the vassal Ampelographic Conservatory, where more than 4,000 varieties from France and cultivars around the world have been conserved and studied for years. So it is also not sure that the Chenin Odyssey will end at Ithaca, and nor will the Chenin replace all of the Vitis vinifera at all, but behind which mermaid do we need to run if we want to ensure its salvation? Thank you so much for your patience.
Voilà. Merci, Patrick. Parfait. So that terminates the first session this morning about terroir and genetics. You are welcome to make your way to the center of the facilities and have a little break, and then we are back here at 11 o'clock. Perfect. 11:30. Otherwise, it will be a little bit of a short break. African time, hein? Donc, on va recommencer, s'il vous plaît. Donc, juste rapidement.
So we're going to start again, not to lose more time. Two things. Please don't leave with your earphones.
When you don't use them, place them on your chair. Don't go home with the earphones. Okay, please. So that's one thing. And second point, this afternoon, we are preparing for the vineyard visits. So just a reminder, il y a 5 routes.
So there are 5 routes. 1, 2, 3, 4, 5. You'll find them on the program. There are 5 to choose from. But you have to give your name in. You choose.
Your mind now. If you set on 2, you are in bus number 2. Do not change buses, okay? You have to be disciplined. Route 3 is completely full, so no more space. And as you walk out, just after lunch at about 1:30, à 13h30, vous allez vous diriger.
You go to the parking, and you'll see that
corresponds to the route that you're going to take. If any of you would like to attend and did not enroll, then your man is André. Where's André? So André will be at the entrance at 13h30. Il sera là à l'entrée à 13h30. Si vous n'êtes pas inscrit, vous pouvez voir.
If your name isn't already on the list, then go and see André.
On the routes this afternoon, in the Herehuis, as we call it, if you go out here and you turn left, there's the Chenin Blanc of the world tasting. So you don't have to go on the route. You can also stay here, be in the garden, and taste wonderful Chenin selection in the building next to the facility. Okay, so you have some options. If you're still not interested in any of that, well, then you can escape to the little town of Stellenbosch to do some shopping or explore. Okay, you are free. So that is just, André, is that in order? Okay. So then, without any further ado, Mademoiselle Rosa, we're going to resume the second part of this morning. Session A2, Climate Change, Search for Answers, is the theme. And Rosa Kruger and Stephanie Midgely, please, if you would come up, and we will discuss Chenin Blanc, new ways and new sites to plant this versatile variety in the quest to deal with climate. Thank you very much.
Thank you so much. Good morning, ladies and gentlemen. Can everybody hear me there at the back, Nolene? Thank you so much for the Chenin Blanc Association International, or International Congress, Ina and Nolene, for inviting the 3 of us here today. Chenin Blanc is a very versatile variety, as we heard this morning, producing many different styles of wines in South Africa. It keeps its unique identity, but seems to change personality and expression to every different landscape. Only in this country, and I know that's quite a brave thing to say, but only in this country can Chenin make wines reflecting the sun and the soil and the way it's cultivated, the altitude and the proximity to the sea so vastly differently. Chenin came to South Africa, as we heard, in 1655, and 52% of our vineyards in South Africa, older than 35 years, is Chenin. It grows in different trellising systems, bush vines, VSP, high wire, raised bush vine, sprawl system, and at different densities in many different climates. We have proven in this country that Chenin can grow well and produce a crop in places of heat and drought and winds. That is why we have started a process of propagating plants from our very oldest Chenin Blanc vineyards in South Africa about 15 years ago, together with Vititech. This will be called our heritage selections, and was chosen from some of our oldest vineyards, Chenin vineyards, that have proven to make great wines, so they had a history of wines, and are able to survive in extreme climates. This is where nature has left us with survival clones. Most of the chosen vineyards that cuttings were taken from are bush vines and dryland farmed. Maybe these selections will, like their parents, be able to survive climate change, because climate change didn't start today. It has been around for a while. It's just happening faster now. And it's nice to see viticulturists here, all of you, and Jaco and Koos and Etienne, welcome, and nice to see you. Some of the best wines, white wines ever produced in South Africa are Chenins. But if we were to plant for the future, and if we were to plant now to grow old, where do we plant? At what density? On which slopes? And at what altitude? How do we know where the best sites are to plant in the light of climate change? Fortunately, science is lending us a helping hand. We have very specific tools in South Africa to go into the essence of every site and every region. These tools can be used to find sites in new landscapes and in new ways to plant to deal with climate change. These models can possibly, Tara is the word, be used in other countries too. Firstly, we can look into the past. We can do an environmental profiling of each specific site, stretching over the last 5 years. TerraClim uses localized weather stations to do this. Then we can also look into the future climate of each wider region. Professor Stephanie Midgley from the Department of Agriculture, Western Cape, and thank you, Ilse Trautmann, for all the work you've done supporting the farmers in this field. Professor Midgley will tell us, Professor Midgley, using international modeling, can tell us how each wine producing area in South Africa is likely to change over the next 30 to 40 years. Professor Midgley will tell us that there's not one single prediction for the whole of the country, but that every region might react to the change in climate differently, depending on the proximity to the sea, the winds, the altitude, etc. Putting these tools together will assist us in planning and designing new sites, or maybe just farming smarter on your own site. If you know the facts of your site, if you know how the climate might change in your site, you can make plans, and you can have a strategy, and you can adapt. Once we have the facts, we can tailor-make viticulture to that site. Low bush vines or Maantjievlag where the winds are too strong, bush vines in stonier soils, shaded goblet where it's hot, very open canopies where spring rains could cause rot in future, etc. There are many models to predict climate change, as you might know, many different interpretations, some quite extreme, but they all have this one message. It will be hotter and it will be drier in wine regions of South Africa. We want our vines to grow 50 or 60 years old, still producing a sustainable crop and making economic sense. Whatever we do, wine growing is still a business, and it must be profitable. When we do the design and planning of a new wine farm or even a new site, we start from scratch. We use GIS to give us an analysis of the terrain. For example, are the slopes facing north, south, east, or west? How steep are they? What is the solar radiation from each site, etc. Then we do a complete soil survey, do a gradient or slope steepness analysis, speak to the people that actually know the land and that have been working on the land for many years. Sometimes the most wisdom lies with the people that have been working on the land. This is why we need, for future and past perspectives, people like Tara and Stephanie to tell us about the history of each site and the future trends for that area. Firstly, please, I ask Professor Stephanie Midgley to take a stand.
Good morning, everybody. It's really wonderful to be here with you this morning, and thank you very much for the invitation to be part of this session. So let's start with where Chenin Blanc is currently planted. This map of the Southwestern Cape shows that the highest percentage of hectares occur just north and just east of Cape Town, but with vineyards extending much further north and to the southeast. We have chosen 6 Chenin Blanc vineyards as case studies in this session, spanning the range of distribution from north to south. The sites are indicated on the map. Each site represents a distinct agroclimatic zone, as you can see in the right-hand map. So the first site, Site 1, right in the north, is at Lutzville, in the northern west coast region, near the mouth of the Olifants River and on the Atlantic Ocean. Site 2 is in the Skurfberg, on the western edge of the Cederberg Mountains. So that's Site 2 there. Site 3 is on the Koa, or the cold Bokkerveld, which is a high-lying interior plateau over there. Site 4 is on the southern slopes of the Kasteelberg, in the coastal plains of the Swartland region, over there. Site 5 is between Cape Town and Stellenbosch on the slopes of the Bottleray Hills, with ocean on 2 sides. So there. And then Site 6 is in the Hemel and Aarde area of the southern coastal area, close to the Indian Ocean, down there. Right, before I turn to the climate trends and futures, I'm just going to briefly summarize the various drivers of regional climate and local weather patterns. So rainfall is produced by 3 main weather processes. Most of the rainfall in our area is brought by frontal systems. These are associated with mid-latitude storm systems, or cyclones, that pass to the south of the country, primarily in winter, but also in spring and in autumn. The second one is orographic rainfall. It's produced in the mountainous areas when the southerly winds carrying moist, warm air off the Agulhas Ocean, or the Agulhas Current to the south, is forced up the mountain slopes. It cools and it forms rain. This kind of rain occurs at any time of the year and is a dominant source of rain for the southern coastal regions. The third one is summer convective rainfall, which is largely concentrated in the summer rainfall regions of the northeastern part of the province, but it does on occasion extend all the way down to Cape Town. Right, let's quickly just run you through what are the main drivers then of our very diverse, very complex climate systems in the Western Cape. The surrounding oceans and the complex mountain topography add a great deal of heterogeneity to the temperature patterns. So the Atlantic Ocean to the west moderates the temperatures along the western coastline, owing to the cold Benguela current that moves north from the Antarctica. The warmer Indian Ocean to the south also has a strong moderating effect on coastal temperature along the southern coastline, owing to the warm Mozambique current, or the Agulhas current, that moves westwards. Then we have sea breezes that develop during the day as a result of more rapid heating of the land, and they can produce almost a 5 degrees cooling along the coastline, sometimes extending tens of kilometers inland, and especially in the afternoons. Along the west coast, fog frequently rolls in from the cold ocean, cooling the air considerably, and especially in the morning. Then added to this is the effect of the mountainous topography, with elevations ranging between 0 and 2,250 meters on the highest mountains, and this over a distance of less than 200 kilometers inland. And as we all know, air temperature falls by around 5 degrees Celsius with every 500 meters above sea level. Then, of course, we have valleys that are isolated from the coastline by the mountain ranges. Some of these valleys can experience very high summer temperatures. The coastal zones and the high-lying plateau are thus cooler during the daytime in summer, and you can see these are marked in the blue and the green on the right-hand side, compared to the hot Cederberg, Olifants River, and Swartland regions. These regions are much warmer, the daytime maximums in summer. The mid to late summer is characterized by strong southerly and southeasterly winds, so over here, coming in off the ocean, and these winds provide much cooler conditions on the southern coast and cooler maximum temperatures along that coast compared to the west coast. Right, and then of course the minimum temperatures in winter, so nighttime temperatures, the high elevation plateau is obviously much colder. You can see the areas that are in blue there are very high elevation. But then we also have two other processes that contribute to cold winter temperatures. The first is nighttime radiative cooling, which is under clear sky conditions where the land surface cools very, very quickly when the sky is clear. And the second one is the cold air brought in over the land during and after cold fronts that bring rainfall. And those determine these winter minimum temperatures. Right, coming to rainfall, there's a very strong gradient or increasing gradient of mean annual rainfall from the semi-arid north to the more temperate south around Cape Town and Stellenbosch, and also east to Hemel en Aarde. Rainfall ranges from less than 100 millimeters per year up here, Lutzville, to around 500 millimeters per year where we are now, and also extending into that southern-eastern region. If we look at the Bokkerveld, there's another gradient of increasing rainfall into the high-lying plateau, the mountainous areas, and some parts of the Bokkerveld can get up to 800 millimeters of rain per year. And then lastly, rainfall seasonality is extremely important. So the western parts of the region that are shown in the dark and the light blue over here, they receive high proportion of the annual rainfall in the core winter season, and our sites 1, 2, 4, and 5 fall into this zone. So these 4 sites here, sites 3 and site 6 are in the green area of seasonal or rainfall seasonality, which means that they receive increasingly more summer rainfall and sometimes also spring and autumn rainfall. So much more moving towards rainfall throughout the year. All right, now let's turn our attention to the scientific analysis of climate trends that have already occurred over the last century. So I'm not going to go into a technical account of the methods used. This is available in the published report of the recently updated climate science study that was done for the Western Cape Province Department of Agriculture. So briefly, there were challenges with obtaining reliable station observation data, and that led us to use alternative data sets for the historical analysis of climatology and trends. So the analysts used 4 different global merged, or what's called reanalysis products, that integrate station observations with satellite proxy data. This very comprehensive study was conducted for us by expert climatologists at the University of Cape Town under the leadership of Dr. Chris Jack. All right, so what did he find? So the first set of maps shows the trends, and this is in degrees Celsius per decade, from 1902 to 2020, and this is daily minimum temperature, the top 2 maps, and daily maximum temperature is the bottom 2 maps. I'm only presenting the summer season trends on the left-hand side and the autumn season trends on the right-hand side. But it's, please note that the autumn season or the spring season trends are very similar to those of autumn on the right-hand side. So first, we're seeing very strong increases in nighttime minimum temperatures in autumn and spring along the entire West Coast region. There's more moderate warming found for the 2 southernmost sites, so Polkadrai and Hemel en Aarde, and across the whole region in summer and in winter. The trends in daily maximum temperature are highest during the shoulder seasons of autumn and spring, and especially in the interior high-lying regions, Cedarburg and going into the plateau area. Daytime warming has been more muted in summer and in winter. So this is in line with a common theme of a stronger climate change signal during the shoulder seasons rather than the core winter and the core summer seasons. In this slide, trends in seasonal mean annual rainfall, and this is in millimeters per decade, are shown for the period 1982 to 2020. And we must just note that this period includes the drought we had from 2015 to 2018. And the diagonal hashing here indicates trends that are not statistically significant. So the strongest trends then are seen in the autumn season across all the zones. As you can see here, almost the whole province drying very significantly, all the zones in the autumn months. The trends in the core winter rainfall, this is this map over here, are quite mixed, and they demonstrate a dipole from the northwest towards the southeast, from drying over here to apparent wetting down in the southeastern part. The Ruins West zone, the one that I've just pointed to here that shows in blue, stands out strongly as behaving very differently to most of the other zones, with stronger while still not statistically significant, but increases in rainfall. The drying in autumn is consistent with the processes identified that led to the day zero drought 2015 to 2018, and also other analyses of climate change in the region. Then similarly, I'm not showing this here, but trends in intense daily rainfall largely follow the spatial pattern and the seasonal variations of total rainfall that I'm showing here, with the strongest decreases in heavy rainfall occurring in autumn and non-significant increases in intense daily rainfall in the Rhones West during both winter and spring. Then, of course, rainfall variability is also very important to consider. So in the next slide, I'm showing the results of the analysis for consecutive dry days, or CDD, or in other words, the dry spell duration. This analysis indicates very weak trends for most of the seasons and most of the regions, except for a very strong increase in the northwest coastal region during autumn, that part there. This is likely the result of a southern shift in cold fronts and their northward extent, which would be the cause of important autumn rainfall events, and these are being reduced as the frontal systems are being pushed south. Some more southern regions, so South 3 to 6, show a reduction in dry spell duration during spring. So you can see the blues, the Souths 3, 4, 5, and 6 over there. Interestingly, this is not aligned with a strong reduction in total rainfall during this season. The analysis suggests that there's a shift towards more frequent but less intense rainfall in spring in this area, and also in the summer in the Rhones West area over there. So more frequent, shorter spacing between the rainfall events, more frequent rainfall events, but not necessarily more rain. Right, the last one then is trends in potential evapotranspiration, or PET. These are consistently positive across all the zones and in all the seasons, although more strongly in spring and in summer, the bottom two maps. These strong trends are particularly evident on the southwestern and the southern coastal plains. Viticulture is also highly impacted by local weather variables such as peak wind strength, incidence of hail and frost, and coastal fog. But long-term systematic data for these variables is very sparse and very difficult to obtain. But I think that Tara is going to address some of these factors for the 6 sites in the next presentation. Right, let's look at the future then. So projections from climate models suggest a further drying associated with hemispheric climatic processes, including a poleward displacement of the westerly wind belts and the storm tracks during the winter rainfall period. And this already seems to be taking place. This appears to lead to a reduction in the frequency of rain days associated with cold fronts passing over. For the climate change projections, the most recently developed ensemble of climate models was used for the period 2030 to 2060. It's important to note that climate modeling does not provide predictions. No one model is correct or incorrect, but modeling does help us to prepare for possible or plausible futures amidst the uncertainty that we have in the science. In order to simplify the application of the climate projections, the scientists used 4 what they call archetype models, which were identified that broadly represent the range of projected changes in temperature and precipitation. So on this axis, temperature change, precipitation change, this is what all the models, the outcomes are, and they've chosen 4 models that represent that range, and that's what I'll be showing in the next few slides. They also take into account some of the spatial patterns of annual rainfall and temperature projections. So the first slide, these maps show the projected changes in annual total rainfall in millimeters for these 4 archetype models. Once again, the diagonal hashing indicates that trends not statistically significant in the futures modeling. The darker red colors indicate drying of around 40 to 80 millimeters per year for the period 2030 to 2060. So in some areas, according to some models, this amounts to around 30% reduction in annual rainfall, but for most regions, the drying is projected to be between about 5 and 15%. The very light blues indicate slight wetting, and there's only really, sorry? Right. There's the pointer. The blues, which are visible on this kind of best case scenario down here, indicate wetting of less than 25 millimeters per year, and that is less than 10% and seen only in some of the models. All right, if you come to temperature, So projected changes in annual mean temperature for the same period. They show a range of possible temperature increases from a low magnitude of around 1.2 degrees Celsius to a high magnitude of around 2.4 degrees Celsius. The low rate of warming projected for the southern coast is noticeable, and warming will likely be stronger in the interior regions with the darker reds. Right, in viticulture, the diurnal temperature range is very important, but further analysis is needed to derive projections for this parameter based on changes in daily minimum and maximum temperature and according to the different models. The diurnal temperature range could increase or decrease depending on the location and the model used, and Tara will also say a little bit more about that parameter later. Right, the last few slides then. A study completed in 2021 for Hortgrow Science, which is the research arm of the deciduous fruit industry, included an analysis of projected changes in seasonal daily positive chill units for the Western Cape. On the left is the historical distribution of total chill units, and that shows the light blue to green areas indicate higher chill, and those are areas suitable for fruit crops. On the right-hand side, we see that by the middle of the century, the climate models project a significant decrease in areas suitable for chill-sensitive crops, particularly in the lower-lying and coastal areas. Interestingly, the Koa-Bokkerveld, over there, the remaining areas of green will still receive enough chilling for even higher chill cultivars. And then lastly, the Hydrological Drought Index, the Standardized Precipitation Evaporation Index, or the SPEI, was modeled from the past into the future and plotted as the number of years per decade where the index is lower than -1. So this represents a moderate drought occurring historically around twice per decade. 3 different model ensembles were used, and the distribution of values from each is shown as what the climatologists call the violin plots, where the bulge of the violin indicates a larger number of models projecting that given value. So the key message here is that mild drought conditions are likely to be far more common into the future across all the zones. The increase in such conditions in the northern zone, so the Cederberg to the Sandford, which is the northernmost plot, is stronger, and the increases in the southern coastal zone, or the Ruins West in the bottom, is somewhat weaker than elsewhere. Important to note is that the increase in frequency of droughts is not limited to mild droughts and extends to droughts of higher severity as well. So in summary, climate change is playing out differently across the Chenin Blanc production regions of South Africa. And the key message is one of continued warming, increasing rainfall variability, and general drying over the next 2 to 3 decades. The mountain and ocean influences will play a large role in the local dynamics of how this all plays out. And even when rainfall decreases are not projected or they do not manifest, increasing temperatures will almost certainly bring significant water balance challenges to grape production. So then we can expect shifts in the current suitability of Chenin Blanc, but also possibilities for new sites becoming suitable in future. Thank you.
Okay, so thank you for the opportunity to be part of this amazing conference and to be in this panel with 2 wonderful experts in viticulture and climate. So I'm going to be talking about what we've done as the South African wine industry from a data integration point of view. A lot of answers. Wat gaan nie aan? Okay. So a lot of answers lie in data integration. There's a lot of climate data available. There's a lot of terrain information available. I just want to get back to my start point, which doesn't seem to be. Okay. So this research has been funded by WineTech, but I'm just going to fall right into how we integrate with this panel discussion. And we look at climate stripes for South Africa, and the stripes vary. Is this the right pointer? And the stripes vary quite significantly. We're getting warmer, but you still have those cooler years amongst the warmer years. So that just shows us the increased seasonal variability within the South African context. And that's why looking at climate change in more detail is really important to us. And looking at
our wine-producing regions are nicely distributed, and throughout that distribution, we've got a lot of different mesoclimatic pockets. And research that I've been focusing on that's slightly different to what Stephanie's been focusing on is using actual weather station data. And when we look at trends of the last 30 years from 1984 to 2015, we can see a marked increase in maximum temperatures, and our minimum temperatures haven't shown such a large increase. We're looking at about 0.6 degrees, and rainfall being sporadic. But if we look at a distribution of climate across the wine-producing areas, these are anomaly analysis graphs. So you've got the zero line. The red bar shows an increase in maximum temperatures. The black line, a decrease in rainfall, and the blue line, a decrease in minimum temperatures. Got so many pointers here. But if we look at the Cape South Coast, shows this, we've had a decrease in rainfall over that period, but an increase in maximum temperatures. And you can see how the profile of maximum temperature increases throughout a spatial distribution. So this, and if I talk about an example, the Breda Kloof area, where some of you will be going, we've seen an increase in rainfall, increase in maximum temperatures, a decrease in minimum temperatures. And that's where Stephanie is talking about the diurnal temperature range. When you've got that shift of decreased minimum temperatures, increased maximum, the diurnal is quite large, so that influences your typicity in your wine and the development of wine styles or cultivar selections. So further to that, I've just laid over this, you can see the green dots. Those are the Chenin Blanc sites I'll be discussing today, where I'm going to be using a data integration approach to extract data from all the layers that we have to see what does the data say. So further to that is how does the plant respond to these environmental parameters is actually where the answers lie. And a study across this climate band where we looked at phenological behavior and tried to identify what climate variables are driving the phenology and which stage is most sensitive to climatic variability. And that was the stage of flowering. And that stage was mostly driven by an increase in maximum temperatures in the range of 35 and 40 degrees in the summer months. So we're looking at from November to March in the South African context, results in our season being earlier and earlier expressions in the September month coming. And we've seen this as a global standard, and we've looked at global climate change predictions is our maximum temperatures in the summer months are going to start increasing, and that's going to drive our phenological responses and change our harvest dates and how we manage our vineyards. And that superimposed with climate change projections of conditions getting warmer across these sites as well as conditions getting drier across these sites drives us to how do we better quantify our environments and how does a grower access all this information. It's very complicated, and that's where we've come with TerraClim, which is an integrated data solution where we stack information, climate, terrain, to identify what is the environmental profiling. And for that, to be a solution, we had to start with building an integrated climate database of 30 years of data. We have a good distribution of weather stations currently. We've had a big drive to improve our weather station network to better understand our local environments. Then we integrate that with terrain information, 2-meter and 5-meter resolutions to provide us with climate maps of hourly, daily, and monthly resolutions for the whole entire year. So it's changing how we look at climates more from a spatial perspective rather than point data. And we create climate maps. So this is the current regional extent that we cover. It covers 98% of the wine-producing areas as well as other crop types. So this data provides us with information, climate maps at farm level. So you've got a weather station in your farm, but now you get a map for your farm for 365 days of the year, 24-hour cycles. So we can start seeing what parts of your farm will result in grapevines having higher water constraints compared to other areas. Where does the sea breeze effect cause recovery in the grapevine sooner than other areas? Then we transition this into temperature threshold maps, which links back to specific crop types, specific cultivars, specific wine styles. And we look at climatic indexes and frost maps, heat maps, which I'll show now. And then all of this culminates into a crop suitability tool, cultivar suitability tool, where we stack different environmental factors, 43 of them, soil, climate, and terrain, to identify what sets that specific site apart, why are some producing better than others. So this is an example of a seasonal variability map over 6 years. This is chill units. You can see the transition of the color distribution from season to season. There's quite a marked difference in spatial distribution. And if I overlay our 6 Chenin Blanc sites that we're discussing, You can see areas that receive lower chill compared to areas that receive higher chill throughout the distribution. Then we transition that to risk assessment maps, which is a standard deviation map of those 5 seasons. And we can start seeing where the darker areas show higher variation in chill from season to season, or chill accumulation, and the lighter areas, less variation. So your in-season management of whether or not you can apply certain practices to enhance your bud break, change your post-harvest irrigation to emphasize better bud break is really important in the areas that are more red compared to the areas that are more white. Then looking at 2 sites that we were going to be discussing. The one site is Roundstone, and the other site is Polkadry. Polkadry receives a nice amount of sea breeze effect, and Roundstone, a little bit further inland, has different climatic dynamics, showing the site-specific variability. If we look at those 2 sites, this is daily positive chill units again. You can see the difference in the 2 sites. What we can extract from these maps is indicators as to the daily positive chill between those 2 sites is fairly consistent, but the chill is different between the 2 sites. You're looking between 500 and 700 and all the way up to about 800. And then looking at growing season temperature between the 2 sites again, you can see the difference in Polkadry having cooler growing season temperature compared to Roundstone. And what this also shows is that Roundstone's growing season temperature is getting slightly cooler over the seasons, whereas Polkadry is a lot more sporadic, and that could be driven by the sea breeze effect. There's also a difference, the site's warmer compared to the Polkadry site. Then looking at hours between 25 and 30, and that's really where this tool becomes of great value for wine decision making. As you start looking at the thresholds, 25 to 30 is scientifically suggested to be optimal photosynthetic activity. So now we look at that range, and you can see that Polkadry compared to Roundstone, the hours between 25 and 30 are decreasing at the Roundstone site and fairly comparable at the Polkadry sites, and that could also be attributed to the sea breeze effect and dynamics in the oceans changing. Stephanie just alluded to the pressure system shifting. Then looking at hours above 30, we also look at hours above 35, 40, and starting to identify how sites are warming and cooling over multiple seasons. Roundstone showing indications of warming from season to season, showing seasonal variability. And Polkadry, but actually decreasing and cooling in the profile of above 30 degrees too, and then Polkadry showing warming in the profile of hours above 30. So that's the kind of data that we can start extracting from this, just demoing the tool. Then we take that further and we start looking at how do profiles compare to one another from an hourly perspective. And if we compare, this is threshold analysis ranging from 0 to 5 degrees all the way to the last gap on the far right is hours above 50, and the multiple lines is multiple seasons. And what you can see over the different seasons is how things are changing. I'm not going to go into a lot of detail and stand still here, but it's just emphasizing what we can extract from data today to aid decision making. But what I do want to show in between these 2 sites, Roundstone and Polkadry, is the nature of this almost a bell-shaped transition for Roundstone. It's got a large profile of temperature ranges, whereas Polkadry, you're looking at most of the hours are between the range of 15 and 30 degrees. So that does have an impact on management and plant water status and phenological developments. Then if we look at what we can also extract is temperatures for Roundstone compared to Polkadry. You can see the temperature range, it's much better here, is about 22 degrees at Roundstone, and then it dips all the way to a comparable minimum temperature between the 2 sites, and Polkadry is about 20 degrees. So on average, it's about 2 degrees difference between the 2 sites. Then if we look at rainfall, the average rainfall between the 2 sites, you can see multiple seasons and the average, but we're looking at about 600 at Roundstone and about 800 at Polkadry. So it just shows that our rainfall changes over short distances within the Western Cape. Our monthly rainfall and frequency of rainfall, more and more in the context of climate change in the Western Cape, we need to start understanding and looking at this in detail, and this is really for, I think, for growers specifically to sit with this data and actually interpret it and play with it. But an example, just to pull it out, is for Roundstone, we're starting to see the amount of rainfall isn't necessarily changing. How the rainfall falls is changing. The frequency, extreme events of a lot of rainfall or light bouts of rainfall for longer periods of time. So starting to see, if you look at June, there's an increase in rainfall in the month of June. decrease of rainfall events in the month of May. So it's showing that the rainfall at Roundstone is actually shifting and condensing into June, July. And if you look at the frequency of rain days, it's actually less. It's decreasing in the month of June for Roundstone. So it's emphasizing that there are more extreme rain events that has an impact on erosion and how you should manage your specific environment over, and this is a trend over 5 seasons, so it gives you an idea of what you're working with. So all of this culminates in the suitability tool, and I'm just going to demo it very quickly. I've got a session after this which I'll speak in a little bit more detail. I'm zooming into Polka Dry. We've developed this. It's based on 43 environmental layers, and you can draw a field. And once you've drawn the field, you can start ingesting the data. We can expand this to collect phenological information, any information. And the idea is that it uses machine learning in the back end, random forest to be specifically, and it mines the data for this 43 layers and identifies what are the top 10 variables that drive the decision as to what you should plant there, or the top 10 variables that you should consider with a greater weighting compared to the other 43 variables. Then you can go graph the profile. On the left-hand side are all 43 variables. You can switch them on and off in interactive profiling. And you can select the blue line is what you've selected. And say if you select seasonal rainfall, summer rainfall, you can update the graph and you've got more variables that you're looking at. Then there are different cultivars in the system, and it's something we're expanding within the wine industry, where you can compare the specific sites, which is the blue line, to Chenin Blanc planted in the area specifically. And you can see what sets this site apart from where the other Chenin Blancs are planted throughout the Western Cape. Then further to that, you can compare fields, which is a very valuable tool if you've got a site that's faring well. And here we're looking at what's the difference between Lutzville and Hemel and Aarde. And I'm going to compare all 6 sites in the next slide. And we're going to show it in a table format. So that's Lutzville that it's just zoomed into. Now it's going to zoom all the way down to Hemel and Aarde, and we're going to select that field. So it also just shows you spatially what area we're covering for the Chenin Blanc production. And then we're going to compare the field. And what it does is that it pulls up the difference in slope is 1% in Lutzville, and then you're looking at almost 10% in Hemel and Aarde. And it just shows it's all the different variables highlighted there, which we'll go into detail in the next slide. So that's the value of the tool, and then you can again go into the view profile, look at the orange line and the blue line, which are the sites that we've selected, and compare that to Chenin Blanc specifically, and identify what sets these sites apart. So what sets them apart is distance to the coast. The 2 sites we've selected is a lot closer to the coast than where the average Chenin Blanc is planted. That drives cooler season temperatures, so we're looking at growing degree days, growing season temperature. What also sets the site apart between the 2 sites itself is aspect, and then looking at soil depth and mean clay. So this gives a very well-rounded approach as to possibly how you should start engaging as a first level when mining your data. So these are all the sites extracted that we're discussing today within the tool. And then I've just overlaid, this is a seasonal index difference for threshold for hours between 25 and 30. And you can see at block level, you can start identifying the variability, the darker areas showing higher variability from season to season, and the hours summated between 25 and 30. So if that links back to your photosynthetic activity, you can start re-looking at some of your in-field vineyard management tools. So this is all the sites extracted, and Risa is going to take the discussion further, but just to highlight is the difference between the sites. So the top 10 variables that we've seen in our analysis that is highlighted as the drivers that you should consider when planting is slope percentage, solar radiation, elevation, distance to coast, mean wind speed, growing degree days, growing season temperature, aspect, mean soil depth, and mean clay, and then rainfall I've put in as a separate discussion point. So those are variables that drive cultivar typicity, cultivar choices, and I'll explain that in my next talk. So we're ranging, there's quite a marked difference in distance to coast, with Roundstone being 50 kilometers from the coast, all the way down to Hemel and Aarde, which is basically on the coast at 4.3 kilometers. But we're going to discuss this in more detail. You've got east-facing slopes, 2 west-facing slopes, 2 south-facing slopes. The soil depth also varies quite drastically, ranging from 800 almost 900 at Polkadry and Roundstone, and then all the way down to 300 and 350 at Himmel and Aarde and Bokkerveld. And Rosa's going to take the discussion further as to what we can do with this data when it comes to decision making. Thank you. Pointed.
Okay, I'm definitely not bright enough to do a pointer and a clicker at the same time. So Nadia is going to handle the clicker, and I'll try and handle the pointer. We've learned some very practical field-level ways over the years to combat climate stress. This is now going down to field level. This is not science. This is practical experience over the years to combat climate stresses and farm in new ways. We're farming closer to nature, or we're trying to farm closer to nature, and flowing with the landscape, adjusting to each site as the landscape demands and prescribes. One of these is contour planting. Contour planting has several advantages. Moet ek stadiger praat, André? Okay. Contour planting has several advantages, mostly to keep rainwater in the soil and direct any runoff water into soft-flowing natural streams to a dam where this water can be reused for irrigation. Every drop of water that falls on your land will have to be harvested in future, a future with less rain. These contour channels you see in the picture reflects the natural lay of the land. Every piece of land on Earth has natural contour lines, unseen though. And the next one is a Google picture of the natural contour channels made by a farmer in Swartland for his wheat fields. Here's the mountain. Now let's try this clicker. There's the mountains at the top, a place with indigenous plants growth, place for animals, birds, and insects to hide and feed, and below are the slopes planted to wheat fields. So this is the top of the mountain. The mountainous area is protected by nature conservation. On this site, there is little erosion, no loss of topsoil, and more moisture kept in the soil. This is an image of the adjacent land where the farmer closed up these contour channels and made straight rows to plant vineyards. He had about, I'm not sure of the exact amount, but I think it was about 50 millimeters of rain over a short period after soil preparation, and these dongas and huge loss of topsoil evident over here and over there. Over there you can see, and over there. Huge loss of topsoil is the result. But this is no criticism. This farmer had his reasons for doing this, and he's actually a very good farmer. One prediction is that rain will be more likely to come down in floods and over a shorter period. That's why we have to go to contour planting. This is a picture, again, of the land right next to the land in the previous slide. Here the farmer did make contours. Planted. Thanks, Nadia, for putting this whole thing together for me. Here the farmer did make contours, planted at higher density bush vines. As the soil was really good, the slope was cooler, and he probably imagined to have a better income from his hand-harvested grapes on this land. The farmer only drives with a tractor between the blocks. That is, where's the pointer? No, wrong one. Those are blocks. And there's the contours. Those are the contours. That's the contours that takes the water away, and these are blocks in between. The farmer only drives with a tractor between the blocks and sprays fungicides from the sides. Each block has 9 rows and is up to 12 to 15 meters wide. He mulches full surface and builds a wonderful soil health, and as such have no compaction in the soil from tractors. So there's no tractor verkeer between the rows. There's 12 rows of vines. What is verkeer in English? There's traffic. There's no tractor traffic between the rows. There's 9 meters of rows with no traffic in between. The next picture, we started We started planting like this on contours in vineyards about 17 years ago on this site, which I absolutely loved, in Franschhoek. The next was in the Overberg Mountains at very high altitude. This was at about 890 meters above sea level. In the hotter years to come, we might have to go higher and cooler, to higher and cooler sites in the Western Cape, like Ceres and Koa Bokkeveld, where we just, Tara graciously and Stephanie showed us the difference that altitude can have. Not everybody, though, can sell their land and move off to a cooler site, of which there are few in this country, but we can look for the cooler, more protected and less exposed sites on your existing land with the help of a tool like Terraclim. This is a farm in Swartland against the slopes of the Kasteelberg, where we planted Syrah, Grenache, Carignan, and some white varieties again on contours. At the top, there's the There's the contours. Those are square lands. I'm not talking about the square lands. I'm talking about the contours here. A proper GIS study at the time showed that the east and south-facing slopes to be the cooler slopes on the farm. The next picture is one of my most favorite sites in the world. This was also planted on Kasteelberg in a slightly flatter area with fynbos strips between the blocks of vineyards, as you can see. These fynbos areas are places for small animals, birds and insects and frogs, also bees to live and feed and migrate to the dam, which is situated a little bit lower down. The fynbos is mostly the same species as what is found on that mountain. On the left is the surveyed and designed map of the land beforehand, and on the right, a picture of the actual planting after two to 3 years. Again, there's contours. These are the contours, and those are the tractor roads between the blocks. And this one, the next one, is our latest attempt in Polkadraai in Stellenbosch, and a much bigger challenge because of the difference in slopes and the directions of the winds. The wind plays a major role on this farm. This is north, that is north up there, and this is south down here, and west and east. We decided, this is the top of the hill, of course. The slopes are facing downwards. This is the top of the hill over there. We decided to keep the highest part of the ridge or the hill to natural vegetation, as this will act as the reservoir for nutrients and moisture for the slopes lower down. Every 50 to 80 meters is a contour channel. There's a contour channel that takes the water away, and this is a contour channel that takes the water away, and the same there. It takes any runoff of water softly away when it rains. And this way, more moisture is kept on the slopes and does not cause erosion. Between blocks, there are the corridors for wildlife again. All the contours lead to a channel over here, a man-made channel, unfortunately, a channel that takes the water down to the dam. From this dam, we can gravity feed, which is very important with the cost of power at the moment in South Africa. From this dam, we can gravity feed the lower lying vineyards, and if the dam overflows, the water will run naturally through an established wetland area. On the right is Chenin Blanc. On the right is Chenin Blanc. Stokpijpalkie or échelon. Do you understand the word échelon, the French? Oh, good. I hope my pronunciation was correct. Échelon, only I don't like planting Chenin échelon because I don't think it's necessary. But this site is windy and we needed to protect the shoots. On the east-facing slopes, you can't see it on this map, but on the east-facing slopes, where there's less wind, we planted Chenin bush vines with a contour, but always trying to avoid in South Africa, making terraces. the landscape here decided the method of pruning and training of the vines. On this very steep section over here, we planted fynbos. This is all fynbos. That's all fynbos. Natural indigenous plantations. And this is all, again, a Stockbypalki Eschala high density. And this is Stockbypalki Eschala, but in tractor rows, because it's a biodynamic farm. These are the actual plantings. This was taken the day after planting of the previous map. The row direction on this farm is crucial. Notice that these rows are planted north-south, only to use the afternoon sea winds to cool down the vines after hot days. In this specific site, the afternoon winds are blowing north-south. In a site not far from there, the afternoon winds can change southeasterly. There are, of course, many other factors to keep in mind when you design like this. Other ways to become more climate resilient is plant acid-retaining varieties, or varieties that ripen before the heat waves, because we know what heat waves do to vines. It strips you of acid and raises your pH. Use less chemical nitrogen and more handmade compost for the reasons I'm sure that will come forth in the tomorrow in the seminar about regenerative farming. And mulch as much as you can under the vines. Always do annual cover crops to build carbon and soil health, preserve moisture, avoid using herbicides, etc. Here we roll down the cover crop in spring to form a mat of materials to stop new weeds emerging, so we don't have to use herbicides. Wetlands. On almost every farm, there are natural lower-lying areas where wetlands can be recreated. I love the use of wetlands because it builds biodiversity of animals and plants on your farm, give water and food to all sorts of kind of wildlife, and it can clean the water coming from your vineyards before it goes into the rivers or into the dams. We know what's happening to our rivers and our dams in this country because of pollution from farms. There are many different ways to fight insects or pests other than insecticides and herbicides. There are just two examples. On this, there's a band of woolly material that stops the snout beetles chowing the vines. And on the other side, there's ducks that love the snails. There's, of course, about 15 other ways to protect your vines from insects other than using chemicals. This is quite a controversial subject, I know, but there are many other ways that VSP, there are many other ways than vertical shoot positioning to grow vines in a hotter climate. Other ways to protect the grapes from direct sunlight. In a study, I think it was done in Australia, it was shown that grapes that are exposed to direct sunlight are up to 15 degrees hotter inside the berry than ambient temperature. The grapes cook, but never really ripen properly. Sprawl or bush vines or eschala are ways to create dappled or filtered sunlight as opposed to direct sunlight. This is a picture of a lovely sprawl vineyard with dappled sunlight throughout the day. If you have to do VSP, and this is just my personal opinion, very personal, because some variety, if you have to do VSP because the variety demands it, please plant in the northwest southeasterly row direction, where the sun goes overhead, over the top of the canopy in the heat of the day. This picture was taken at 2:15 in the hottest part of the day, with the sun perfectly overhead and less chance of sunburn directly on the grapes. This is a raised bush vine. I love this vineyard. It's a Palomino vineyard in Pekinisch Kloof. It's very, very old. But here you see again the natural umbrella that the shoots and the leaves form, protecting the grapes from direct sunlight. With the increase in hot days and less rain forecasted for the future, we have to grow smaller, leaner, less vigorous vines. Vines that will use less water in summer and lose less water from big leaves in the heat of the day. This farmer will probably fertilize, he probably did fertilize a lot here and irrigated a lot. And now we'll have to top these vigorous vines, take all this excessive shoots away and lose all that energy. we will be forced to use less water in future. We wouldn't have a choice. If you don't test the moisture in your soil, you'll never know how much and when to irrigate, if you can irrigate. We've used 60% less water on some farms only because we mulched under the vines and because we measure on a weekly basis how much moisture there's actually in the soil. This is a neutron probe reading by people that I've been working with for the last 20 years. This is the Echelon vineyard again with protection of the grapes against the sun because they hang within the cover of the leaves. The protect your buildup of reserves post-harvest, with Tara telling us and Stephanie that we're going to have less rain in autumn. So you can't fertilize in autumn in the dryland areas. You'll have to protect your reserves in many various different ways in autumn. Healthy soils are of the utmost importance in the fight against climatic stresses. These are the advantages of microbial life in soils. I'll read through it quickly. You can read it yourself as well. It retains more moisture during hot months. It helps control weeds. It keeps the soil temperatures down in the heat wave. It stops erosion. It helps fight compaction. It decreases the rate of evapotranspiration. It increases the uptake of the natural nutrients in the soil, minerals in the soil. It loosens up your soil, making it more porous. It increases root development substantially. And it might retain acidity in the grapes at harvest, one thing we're all looking for. And it might result in earlier harvesting dates. I say might because I've done this research only on one farm over the last 5 years, where we have very, very healthy soils. And they harvest almost a week earlier than the neighbors. Now my papers are all confused here. Tara and Stephen has put together a schedule of 6 areas and highlighted the climatic factors of each, as you've seen in the previous slide by Tara. Now I'm going to grill these two with questions. I think you need a... Andre, would you please assist there? This is the comparison between climatic areas, difference in rainfall, all the different climatic parameters that Tara and Stephanie has analyzed for us. If you know what the difference is, you can with much more knowledge plant your site in future. Hemel and Aarde, this is a specific site. This specific site that I know quite well is only 4 kilometers from the sea. The average wind here is higher than the rest, as you can see. Where's Hemel and Aarde? Oh, no. Who's pointing? Nod, are you pointing for me? Wonderful, thank you. At 6.4, the average wind is higher than the rest. Can we tell what kind of wind it is, Tara? And what is the effect will be of this different wind than the rest of the country on the vines?
So with Hemel and Aarde compared to the other site, Hemel and Aarde has got 6.4 meters per second as an average, so there's also gusts that are a lot higher than that. So a vine's optimal photosynthetic activity is also, it starts shutting down by 4 meters per second, winds higher than that.
Sorry, Tara, just for the people that know Hemel and Aarde. Hemel and Aarde is on the?
South coast.
The south coast, and where they grow mainly Pinot Noir and Chardonnay.
So that's the last point, number 6. It's close to the ocean, but the winds that you get in that area are a lot harsher. It's southerly winds, and then they blow up against the topographic features. There's like a mountain range behind it. It comes back down. So there's a lot of gusts, and it's not always positive for photosynthetic activity, I think is what I'm trying to say.
Thank you so much. Stephanie, this area seems to be getting more summer rain in future. This will, of course, have an effect on the health of the vines and the grapes. And vine canopies will have to be opened up more to prevent disease and rot. Is that a possibility? And how much more rain and when can we expect this rain? That's going to fall more on the southerly parts of the wine-growing areas.
Yeah, so the analysis I showed in my presentation shows that this area has been getting wetter in the last 40 years. It's also getting more intense rainfall. And climatologists have actually done a study on that could explain why this is happening. And it seems that the Agulhas current to the south of the southern coast is actually getting warmer. And this is intensifying the southerly and southeasterly winds that are coming onshore. And they're bringing moist, the warm ocean current and the moist air comes in overland, and particularly because the mountain range there as well, and it drops the rain there. And that seems to be the reason why it's getting wetter. And the models for the future also are taking that into account. And quite a few of the models are projecting that this area might be getting wetter. But can I just say that there is a lot of variance between the models, and overall, there's a lot of uncertainty about what is going to happen in the future. It could be a little bit wetter in future, but there's also a high chance that it could actually be getting dry like the rest of the region.
Thank you, Stephanie. In Lutzville, an area that I really like, just show on the map, please, Nadia, where it is. On the map on that side, yes. It's a very interesting area. It's up north, it's far away from here. It's mostly, why are you three laughing? It is far away from here. It's up there, yes. The winemakers at Lutzville, Sellers, Higu, and some of the farmers approached me a while ago about old vines in that area. They produced, on old vines, 23 tons per hectare Chenin, but they just made a bulk wine from it. So they asked me what to do. But they wanted to make a wine of a higher quality. I suggested that they cut the irrigation, that they fertilize less, and they do good shoot thinning. They did that and made a wine. We've tasted the wine, Andre and myself and Nadia. We tasted the wine with substantial higher quality and a much better price for that season. So it's not only about the terroir, it is also about the farming practices, and always, of course, about the price point of the wine. Stephanie, tell us about your experience in Ebenezer, which is an area quite close by there.
Yes, so Ebenezer is a community of smallholder farmers, an older community that is situated about halfway between Lutzville and the coast, so towards the ocean. And because they're closer to the ocean, in the past they've always got a lot of fog coming in over the cold current on the Atlantic side comes in and brings in the fog all the way through to Ebenezer and past the Ebenezer farms. And they used to benefit from this cooler microclimate. And they grow a lot of vegetables there. And so the mornings are much cooler. The crops are much more protected from the sun and the heat for a large part of the day. And then the fog dissipates. But what they told me was that over the years, they've been getting less and less fog. Or the fog is not coming in as far inland as it used to. It gets stuck close to the coast, and they're not benefiting from that anymore. And they actually had some serious crop losses in the last few years, tomatoes, burning on the plant and so on. So what seems to be happening is that scientists have been saying that in this part of the world, the high pressure systems coming from the north are pushing further south and are causing the fogs not to come inland as much as they used to. And that is something that's being picked up by a number of scientists.
Thank you so much, Stephanie. Go Bokkenveld. Nadia, where's that? You with the clicker? Oh, wonderful. We always say, when we try to plant for the future, go higher and go cooler. And in Go Bokkenveld, at an altitude of 1,036 meters above sea level, that is what you have. For every 100 meters, like Stephanie mentioned before, 100 meters high in altitude, the summer temperatures drop with 1 degree. I've tasted the first Grenache Noir that Lucas van Lochenberg made last Friday from that vineyard there in the Go Bokkenveld, and it was just a lovely vineyard with length and a natural acidity. Tara, the annual shifts and the effect here. Are you happy with that question?
Yeah, that's fine. So the Go Bokkenveld, we can see it's increasing. So it's high solar radiation and it's extreme conditions. It gets very cold, it gets very hot, it's more inland. But what we're seeing with climate change and what Stephanie is showing is that our maximum temperatures are increasing, minimum not so much. So the range between diurnal temperature is actually getting more. So that has an impact on your acidity, your wine style, and the development in the wine. So that's all I really have to say there.
And if you know about that, you know what to do viticulturally.
Yeah.
Skurfberg, which is an area that I really, really love, where some of the country's best wines and best Chenins have ever been produced. In 2015 to 18, this area had very little rain and a very small crop, as most of the vineyards are dry land. Stephanie, some of the climatologists predicts a cycle of dry years. In other words, a repeat of what happened in 2015 to 2018, where we had almost no rain. Is that possible again? Do you think this area up the west coast will be increasing in temperature than more other wine-growing areas? Is that true? But they're so close to the ocean, wouldn't the Colbenguela currents cool them down at night sufficiently?
Yeah, so this area took a really bad knock during the drought and really suffered quite badly. But droughts are normal and dry cycles are normal. It's just that climate change is now just loading the dice towards more frequent and more intense dry periods and severe droughts as well. So we are going to have another severe drought. We just don't know when, but the risks are changing. So where we might have had a drought like that 1 in 100 years or 1 in 200 years, that might be changing to 1 in 50 years or even less than that. So we don't know whether we might have a drought like that again in 10 or 15 years. So it's possible. But certainly that part, the northern part and the inland part of the Western Cape, it looks like the modeling is saying that those areas are going to be more prone to more frequent and more severe droughts.
Not good news. Nadia? We're done there. It's the next. Do I have another? Oh, of course, sorry. Polkadrai. I've been involved in a vineyard in Polkadrai for the last 8 years, and the southerly winds play a major role, as I've explained previously. What is standing out in the schedule of the soil, what is standing out is the soil depth. But Tara, the effect of climate change here could be different within a short period because of the mountains. So on one side, you could have quite a dramatic increase, but not on the other side.
So Polkadrai is a very dynamic area. It gets really nice sea breeze effects, but there's also a lot of different aspects and slope angles, and the percentage of slope changes quite drastically in that area. And you can get really nice wine styles coming out of that area. So your northerly slopes and your west-facing slopes are slightly warmer, and then your south-facing slopes and your east-facing slopes are slightly cooler. So taking advantage of those dynamics, and that's where with Terraclim we can start seeing those small dynamics over short distances that really sets a region and area apart.
Thank you, Tara and Stephanie. Chenin has changed and adapted in this country for the last 350 years, a time which has seen climate change already. 15 years ago, we decided to start to take cuttings of some of our oldest surviving vineyards in South Africa with the help of Vititech. They cleaned them up of all known viruses and started new planting material from them. This year, we are planting a wonderful selection of these vines, mostly Chenin, in this remote farm up the west coast called Pietersklip. It's quite close to Skurfback, but higher, a bit cooler, and a little bit more water. It's up the west coast. This is I'm never sure with Johan Burger around if you could call it a clone, a selection, a variety. This would probably be a clonal selection. It is the area surrounded by 600 meters of natural indigenous fynbos and some rooibos tea. It is a great area. Cuttings of these Nolene will be available within the next 2 to 3 years. Am I right, Charles? The next 3 years, yes. This is the list of the sites where the cuttings were taken from initially. The new vines will be clones or selections of Chenin from our oldest vines that have stood strong and firm against our extreme climate. They will be vines with purely South African survival wisdom. Thank you so much, and thanks all for listening.
Tara. Excuse me, just 1 second. Tara, I think you still have something to say. But instead of your 25 minutes, it's 10 minutes. Can you do it? But don't talk too fast for the translation, eh?
Yeah.
Okay.
I'm just going to skip a few slides.
It's a tall order.
So it was a bit awkward because I was part of this panel discussion, but I actually have to give context on what Terraclim is and what we've developed as a South African tool, which is now a company that we are serving the agricultural sector with. So Terraclim integrates terrain and climates, and I'm going to skip through a few slides, but the aim of this discussion was to take the top select five wines of the Chenin Blancs that have been winning consistently over the last few years, and see if Terraclim could identify any variables that are consistent. So what we do is that we look at what is happening on a specific site, and it's really bad to skip through slides if we really are tight on time. So again, it comes back to what is the revealer of place, which is the Chenin Blanc, and we want to use Terraclim to see if we can identify a revealer of place. What we can see in Chenin Blanc is that it covers 16,000 hectares in our South African wine producing area. But where site selection becomes really important is that we want to start producing older and older vines to produce better quality wines. And that's why the site selection is so important. And to start identifying what's happened in the last 30 years to really dictate what's your decision making for the next 30, 40, 50 years. And if we look at the Chenin Blanc distribution, it is throughout the Western Cape, with the largest amounts of Chenin Blanc production being Breede Kloof, Olifantsrivier, and Paarl, which is these warmer areas where we are seeing shifts in rainfall, drier conditions, and we are seeing shifts in diurnal temperatures. So that does link back to viticultural practices. So Terraclim is enabling climate-smart adaptation, climate-smart mitigation. And if we look at, and it becomes a very important tool because of what vineyard costs are. You're looking between $20,000 and $40,000 per hectare. So it's a big investment, and you want a long-term investment. So with Terraclim, we are empowering farmers to make better decisions. And to come back to our solution, which is the producing climate maps, so we can get to a decision-making tool. But over and above expanding our weather station network, we also have logger expansions in high-density areas like the Bunnock Valley. We've got 50 loggers. We want to better understand the climatic dynamics, how temperature links and correlates with solar radiation and aspect and slope in more detail. And these are, like I said in the previous assessment, what we can do with this data: risk assessment, frost assessment maps, and we cover multiple crop types. So in the long term, it's to get the farmer to start not just looking at wine grapes, but to start, how do we take full advantage of our whole environment to actually be economically sustainable? Maybe plant some sweet potatoes or other crops to diversify within your environment. So this is a WineTech funded project. It's been running for quite a few years, since 2018. It started with a wine industry pilot study where we try to identify what is the wine industry, researchers, consultants, and farmers need in the context of climate change. And the overarching voice was access to climate data and access to terrain information. That is freely available in other countries. We've had a big drive to improve our weather station network and our data collection processes, and to automate that so it comes into a system real time, we clean it, we streamline it so that it improves research in South African context. And we started with a pilot phase to identify, is this of value to the industry? And we now cover 98% of the wine producing area. It's in different blocks because each block has a different spatial interpolation method that creates that specific map. So each block has a different accuracy assessment to it. Areas like Yemmel and Arde have very low accuracies because of the climatic dynamics, and to fix that problem, we have to install new weather stations. So this has opened up the door to partner more closely with farmers in the context of research. So what we do is provide information to help the limited accessibility to climate change knowledge from a terrain and climate perspective. The services we provide, Terraclim, can be disseminated in different forms through a web app, an API. We have a suitability bespoke decision-making tool, and consulting and research. We cover multiple crop types. The web app works very similar to Google Earth. And what this web app is meant to do is provide a farmer with the ability to search to a specific field. I'm going to eventually search through the tool and land on the site on the top right-hand corner, which is a vineyard that I monitor that has a difference between the high vigor and low vigor, as well as an apple orchard at the upper part of the vineyard. So what the tool, it's very easy to navigate to a specific site, and once you land on the site, you can navigate through different terrain variables, climate variables, to get insights as to what's happening within your specific field. And currently loaded is slope, and you can see the variation at block level. Terrain wetness, this is aspect. You can see the aspect for grapes is different to the aspect for apples. And terrain wetness index, you can see why the bottom of the block is high vigor compared to the upper part of the block, which is low vigor. There's higher water holding capacity, which is water availability. That linked with solar radiation explains why, again, solar radiation is higher in wine grapes compared to the apples on farm level. Then looking at temperature profiling at field level, how it transitions within the block. There's a distinct difference between the upper and the lower part of the block, indicating high vigor, low vigor. You can also see when you start looking at bioclimatic indices, which are also loaded here over multiple seasons, why apples, you can see it's cooler there, it's got a higher chill there, as to why wine grapes are the bottom part of the farm and apples on the higher part of the farm. Just shows in the context of climate change the need to start diversifying crop types on a specific land, and these are high value and high investment crops. And further to that, what we've developed, so this is hours above 30 and 40, you can see the difference within the block. You can go to view profile, you have a login functionality, it's still currently freely available. But what's nice about the tool is that you land on a climate dashboard. You can select your crop type, and you can then profile your whole entire farm. And within that, you also get context as to what are the bioclimatic indices that are currently available in the research space, what are the terrain variables that you should consider in decision making, and it explains each one of those variables and contextualizes it in the context of what is an international standard and what is an industry standard. There's an example of growing degree days, what the index is, what your values are, and how it compares to an international standard. So it's also a marketing tool. I get a lot of questions from certain areas. Are we warmer than that area, or cooler than that area? And this tool can start providing those answers. And then the climate profiling is the nicest part about the tool. It's an interactive tool, so a farmer is the best person to quantify the climatic environment at the end of a season, what happened, what season does it compare to. And if I zoom into October, which is the orange line, 2018, there we had a very big spike between our maximum and minimum temperatures, which was almost a 20-degree difference, and that linked to our harvest being 11% lower than the average. The cell division and cell expansion didn't really happen in that time. So smaller berries were reported in certain areas and less berries in other areas. Diurnal temperature differences, you can see the difference over multiple months and over different seasons and how the diurnal temperature profile is actually changing. And you can start understanding that in more detail. So that's basically what the tool does. And you can also generate farm reports that provides all your terrain and climate information. And API, you can get risk assessment maps. I'm flying through this. This is a map which we created for hours above 35 and 40, which linked to earlier flowering in the next season. So it's a summer temperature map. So hours between 35 and 40 for the month of November and to March, summated. The darker areas indicate areas, and it links directly to flowering. Areas that you can have earlier flowering is the darker red Robertson area, compared to Cape South Coast, coastal areas where you're going to have later flowering because there's less hours between 35 and 40. Further to that, and this also integrates well, and there are studies that show that we're seeing the same trends in other crop types such as apples. Then that's where crop response modeling becomes a very valuable tool. So we can take 5 years of data and link it back to crop responses and start identifying how is climate responding to crop responses. Then to zoom into a certain part of this map, this is near the Polka Dry area. These lighter areas have less hours between 35 and 40, and I sat with a consultant and a farmer, and the farmer was absolutely amazed, as was the consultant, that all the lighter color areas is where they buy higher quality wines. And these valley bottoms have more hours between 35 and 40 in the summer months, and different soil types, but they struggle to attain higher quality wines. So from the start, they should be more focused on higher yielding wines rather than higher quality wines. Then the bespoke decision-making tool, I'm not going to go into the detail of that as much as I'd like to, but everybody wants to have lunch. What I'm going to get to now is we've taken the Chenin Blanc winners again this year. We've selected 5 winners. And just linking back to the amazing work that Chenin Blanc has done, styles, typicity, we can start using tools of this nature to start getting more and more answers as to the whys and the hows within Chenin Blanc. So we've selected 5 of the wines, and the question was what makes a winning Chenin, and we're going from a data-driven approach. So the sites are mostly within this area, and if we zoom into those areas, the sites we selected was Kaapzig, De Morganzon, Speer, Stellenrust, and Kleine Zalse. And zooming in a little bit further, you can see from a climatic perspective, this is an average growing season temperature map. The sites are fairly comparable when it comes to growing season temperature. I have not put where the actual vineyards are. I've just put the main farms because some of the farms said we should keep that secret. So here's an extraction of one of the sites. So this is the Morganzon. I'm going to fly through it and then have a table at the end. The next site is Kaapzicht. The next site is Speer. Different sites that make up Kleine Zalse. And then that culminating again over multiple sites, comparing what are the different variables, culminated into a table. So that's what the table looks like. Overarching, overall, it emphasizes that each site, Chenin Blanc really is a revealer of place. It shows the typicity of its localized environment. And what we can see is not very well highlighted here, but the solar radiation is fairly comparable over all the sites. The growing degree days and the growing season temperature is also comparable. If we look at the growing season temperature, it's all within the range of 18.6 to 19 degrees. So it's all within that profile of growing season temperature. And if we look at the rainfall, it's all in fairly low rainfall areas, summer rainfall areas. So those are the major overarching comparable factors, growing season temperature. So what we can do, if we have more detail of this nature, we can start looking at Chenin Blanc suitability maps. We've started to look at some of those, but it's too preliminary to show anything. But yeah, the conclusion is that TerraClim provides information to your block and farm level, and for just emphasizing again that Chenin Blanc does really pick up its localized environment and expresses it through the wine, and there isn't really an overarching answer as to this is it. And that concludes my 25-minute presentation.
Thank you, Tara. Thank you, Tara. And apologies for rushing you, because it is truly fascinating. And when we see where we are going, we so badly need this. And thank you very much for the intervention. Really enjoyed it. Maybe just a last word. Is it Lucinda? Lucinda Haynes from WineTech. Lucinda, just to conclude. And then, ladies and gentlemen, you can have lunch. And it's not going to be a French. C'est pas un déjeuner français. Hein? Il va falloir manger.
It's not, unfortunately, a French lunch. You'll have to eat quickly.
I am what is standing between you and your lunch, so I do promise to keep this very short and sweet. I am going to give a very brief overview of WineTech and how WineTech creates opportunities for sustainability, how WineTech creates opportunity for science and research to contribute to a sustainable future for both viticulture and winemaking. So WineTech is an independent South African wine industry non-profit company, and we receive our funding primarily through statutory levies that all wine grape producers and sellers pay, and then we also leverage additional funding through other governmental institutions. But our main responsibility is to fund research in the wine industry, as well as innovation, knowledge transfer, and people development. The long-term sustainability of the South African wine industry is really at WineTech's core purpose, and this is really the lens that we look through when we decide which research projects to fund. So WineTech gives really strong preference to research projects that will ultimately deliver practical benefits to the industry, while also contributing to economic and environmental sustainability. So all our activities really contribute to improving the management of our natural resources, promoting financial viability, and then supporting our human resources as well. Our research portfolio consists of flagship programs, viticulture research, and enology. And our flagship research programs, we've got 3 different programs. The one focuses primarily on climate change, and that is mainly the TerraClim project, which is what Tara just discussed, and you've heard a lot about that this morning. The other flagship program focuses on projects that help us to optimize water use efficiency in vineyards. And there are 3 aspects to this research program. In the one part, we evaluate different technologies for data collection in vineyards. The other part of this program is where we have field trials in different regions in the wine growing regions, where we evaluate different irrigation strategies to also help inform producers on what the better decisions are to make. And then the third part of the project is establishing a model vineyard where we can study vine responses to stress. And that project will also be discussed in more detail tomorrow by the researchers involved. Our viticulture portfolio covers projects related to soil and water management, grapevine improvement, terroir, cultivation, and the management of pests, diseases, insects, and bacteria in order to ultimately contribute to financial and environmental sustainability. Our enology portfolio primarily focuses on research that helps us to develop new analytical methods or improving processes that will improve our wine quality, because we do believe that if we can improve wine quality, we can demand higher prices for our wines and in that way help the profitability of producers. WineTech then also contributes or creates innovation through both domestic research partnerships and global partnerships with other research institutions and agri-innovation entities. And then we share this innovation for collective profitability and long-term success. Our learning and development and knowledge transfer initiatives really act as a catalyst for learning with the aim to grow the learning culture of our wine industry. So WineTech acts as an intermediary between, in the knowledge exchange process between academics and the industry. And this is done using various platforms, including publications, articles, the support of technical information days, study groups, and workshops. So the aim is to increase the pool of knowledge of our industry members, because we do believe that when people are more informed, they can make better decisions in their businesses, and in that way they can also, or it also encourages them to promote different, or to adopt innovations within their own businesses. Over the years, WineTech has funded a lot of research that's very specific to Chenin Blanc as well. A lot of these projects are going to be discussed in much more detail at the conference, so I encourage you to keep an eye out for the WineTech logo for more or to see which projects are funded by us. Then in your conference pack, you would have received this booklet, which basically is a short summary of all the research projects that WineTech is currently funding. And then I also would like to invite you to visit our website, www.winetech.co.za, for more information about the research that we do, especially on Chenin Blanc. Merci beaucoup.
So that concludes our session for this morning. Thank you very much for all the speakers. Merci beaucoup pour l'intervention aussi ce matin. Petit changement.
So now we're going to have a little change of program. We're going to, on se rencontre donc à 13h50.
Il y a ça et il y a route 1 and 3 that's complete. It's completely full. So either you stay behind and have a wonderful lunch and have some Chenin tasting, or you see André for alternatives. Merci beaucoup. Bon après-midi.